What's up, John?
Hey, you ready?
Yeah, man, I'm just listening to audio osmosis.
All
Got
right.
some good music on that CD.
Well, good. I hope you're ready. We're doing test 3.
Right, test 3, and I'm ready.
Okay. Test 3, passage 1. I guess I'll start?
Yeah, why don't you? Passage 1?
Good enough.
Physical
Passage
sciences.
1. An alloy of gold and copper contains equal molar amounts of both metals. According to the gold purity scale, this alloy will be... What do you need to know about the gold purity scale for MCAT?
I don't know. I mean, if you're going to buy
Nothing.
a ring, you'd probably need a lot, but...
Nothing, right? For MCAT, nothing.
For MCAT, right, nothing.
So we look in the passage and we see that it says the fractional mass of gold in a gold alloy is given in carats as an equal fraction of 24. I'm not sure what that means. And of course, since I'm not sure, they told me. A 14-karat gold ring is 14 parts gold and 10 parts copper. Okay, so here they tell us that an alloy of gold and copper contains equal molar amounts of both metals. According to the gold purity scale, this alloy would be. So if it has equal molar amounts, does that mean it has equal weights?
It does not, because one is heavier and has a greater molecular weight than the other.
Exactly. So what we have to do is go to the periodic table to find out the weight ratio of gold to copper. And we see that gold is 197, and then we look at copper, and copper is 63. So it looks to me like gold is about 3 times heavier than copper. If gold is 3 times heavier than copper, and we have equal molar amounts, that means we have 3 times as much weight. So in other words, we have 3 parts gold, 1 part copper. So if we take 24 and we divide it into these 4 parts, 24 divided by 4 is 6, so it's going to be 6, we have 6 parts copper, and then we have 18 parts gold. So it should be 18 karat gold, and that's answer choice C. Question 2. The cast iron used for cookware has a carbon content about 2% by mass. Cast iron is. So what we have here is we have an alloy. We have iron with carbon injected into it. And it said in the passage, in the bottom of the second paragraph, carbon is added to iron to make cast iron, which is stronger and harder than pure iron. So it's harder. Then we have to put that together with the last paragraph, where it says, because of this, interstitial alloys have a added hardness. So interstitial gives it the added hardness.
Got it.
So we take a look. It's interstitial, which is A or B, and then whose carbon atoms increase bond strength in the solid without disturbing its structure, and that is the description of the interstitial from that last paragraph. So answer choice A. Number 3, an engineer is in search of a metal that is highly ductile with poor electrical conductivity. Which metal from table 1 is the best choice for the engineer? Well, I happen to have table 1 here. If we take a look at table 1, now, what do we want? We want
it highly ductile with poor electrical conductivity. So highly ductile.
And ductile means?
Malleable.
Yeah, like malleable. It means malleable means to hammer it out with a mallet, I like to think of, in flat sheets. Ductile means to stretch it out into wire. So a Young's modulus, that's what we have here. How does that relate to ductility?
Well, Young's modulus is a constant which is going to describe stress over strain, or the amount of strain that will happen given a certain amount of stress.
And yeah, and stress then is the strain is how the thing changes, and stress is what we apply to it. So basically what it's saying is something like Jell-O has a low Young's modulus, and something like steel that's very stiff has a high Young's modulus. So ductility, something that would be ductile, we're looking for something with a low Young's modulus. We take a look here, and copper is our best choice for lowest Young's modulus. And then also, it asks us about...
It asks about
electrical conductivity.
We're looking for poor electrical conductivity. So we're looking for something that is more resistant.
Highly ductile and low electrical conductivity. So if we take a look at conductivity, we want high resistance. And high resistance is going to give us lead, 0.27. And we'll go back to copper now, 0.02. So what's the best answer here? It was going to be copper or lead, because we've got a discrepancy.
Yeah, well, the Young's modulus, to me, those numbers look really similar.
Exactly. Look at the numbers, 120, 91. Then we drop, and these two numbers are very low. 70, we're back up. So copper and lead are both pretty low on the Young's modulus, which we want. But then over here in resistance, 0.27, look at the numbers, 0.1, this about 0.1, 0.02, very low resistance. And actually we know copper is very highly conductive. So copper is a bad answer. Lead becomes our best choice. Lead is choice D. Question number 4. A copper wire with a 1 millimeter diameter carries charge over a distance of 1 kilometer. If 5 coulombs of charge are transferred per second, what is the power dissipated in the wire? So they're asking us for power, and that's the first place I'm going to go is to the answer, what are they looking for? They're looking for power. So I need an equation with power. The most common one, power equals IV, current times voltage. Now, they don't give me current, or do they?
Well, in the question, they write, if 5 coulombs of charge are transferred per second, so they're saying 5 coulombs per second, although it's not in the sort of format that we'd be used to seeing it.
Exactly. What they're giving me coulombs per second, and a coulomb per second is an amp. And so they're kind of disguising what an amp is. And they're going to do this a lot. They may give you joules are spent each second. Well, a joule per second is
a watt.
A watt. So you got to look for that. So they do give me current. They give me current is 5. Now, what about voltage? I don't have voltage here. And if I look at table 1, I still don't have voltage. All right, so I'm gonna have to find a different formula. And what do I have from table 1 that might be useful? I have resistance. Do I know a power formula in terms of resistance? I do. If I take voltage equals IR, this is Ohm's law, and I take IR and plug it in for V, I end up getting power equals I squared R. So now I have I, and I actually also have R. We look over here, and copper is 0.02, and this is ohms per meter. So it's not just ohms, it's ohms per meter. They told me then I've got a kilometer long. So my formula is going to look like this. 5 amps squared times 0.2 ohms per meter. I'm going to have to get rid of those meters. To get rid of those meters, I'm going to multiply by
1,000 meters per kilometer.
Meters per kilometer, correct. 1,000. And this is going to give me it's actually going to give me my watts per kilometer. And the funny thing is here, that's what the question is really asking. Even though the answer choice is in watts, it says charge over a distance of a kilometer. So it's watts per kilometer. All right. What about that 1 millimeter in the problem?
The 1 millimeter is just referred to here because it says the data is given.
Another red herring. Exactly. Okay. So what we have then is power equals 25 times 0.02 times 1,000 is going to be 20. So power equals 500 watts. Question 5. Gold and silver have been used as a currency for thousands of years. An advantage of gold and silver over other metals that makes them useful for currency is that they're. Now, that they're what? This question is asking you about a basic concept in science, and that is, are you aware that money metals don't like to be oxidized? Now, oxidation is really rust, right? When you oxidize something, you lose electrons. So what are the money metals? Gold, silver, mercury, and nickel is a money metal, but it's the one that it can be rusted a little bit. But basically, they're asking about gold and silver. So we know they don't like to be oxidized. Now, if they don't like to be oxidized, that means they are weak reducing agents. Remember, the thing being oxidized then is giving up electrons to somebody else, and so it's reducing something else. If I'm giving electrons to Jordan, I'm being oxidized, I'm reducing Jordan. So answer here is C. Weakness as reducing agents makes them unreactive.
Which is a really funny way of putting the science there. I mean, you could ask that question in a simpler way. What is true about money metals? They don't like to be oxidized, and that would be simple. But to put it in the reverse, sort of, make it what is true of money metals, their weakness as reducing agents, a lot of students will read right over that, and they won't see the science within it.
Right. Okay, question 6. 3 10-meter lengths of aluminum wire, 1 millimeter thick. There's that 1 millimeter again, so we're probably going to refer to table 1. 3 10-meter lengths of wire, aluminum wire, 1 millimeter thick, are connected in parallel to a 100-volt power source. What is the equivalent resistance of the parallel wire system? Let's take a look at what this would look like. We've got our 100-volt battery. That's our power source. And then over here, there are going to be 3 wires connected, and we will connect them in parallel, as they said. 1, 2, 3. And these wires connected in parallel are basically resistors. Now, what is the resistance of these 3 wires? And they said they're aluminum, so we take a look at aluminum. We get 0.03 ohms, again, per meter. And it told us they are 10 meters in length. So the resistance is going to be 0.03 times 10, right? Ohms per meter times meters, which gives me 0.3 ohms. So each one is 0.3 ohms. 0.3 and 0.3. The formula for this, if you wanted to use the formula, is 1 over R effective. That's the effective resistance of that whole section of the circuit there, equals 1 over R1 plus 1 over R2 plus 1 over R3. So we end up with 1 over R effective equals 1 over 0.3 plus 1 over 0.3 plus 1 over 0.3. And what the math comes out to being what?
3 over point.
The math is difficult, right?
Yeah.
If you look at this, and actually there's a little trick here, and it's not necessarily difficult, it's just a little bit tricky, and it can throw you off. But if you really, and they pick the same number on purpose, because there's a rule about putting resistors in parallel. If you've got, if they all have the same resistance, and you've got 3 resistors, the total resistance is divided by 3. If they all have the same resistance, you had 2 resistors, the total resistance is one of them divided by 2. If you had 4, it's divided by 4. So here, the total resistance is going to be 0.3 divided by 3, or 0.1. So the effective resistance is 0.1 ohms. Answer choice B.
You ready to do passage 2?
Yeah, I'm ready.
John, I'm trying to get ready to battle the space aliens. I can't go to space without being ready.
All right, so passage 2 is on rockets then.
It sure is.
Okay.
Question 7. Which of the following is true of reaction 1? Well, I just happen to have a slide of reaction 1. Let's throw it up on the board. We've got reaction 1. And reaction 1, at first glance, fairly complex reaction. Bunch going on. Let's see if we can break it down, see what's, look at the answer choices and see if we can get a clue as to what exactly we're looking at. A says nitrogen is oxidized chlorine. So we're going to have to consider the nitrogen and the chlorine here, or C and D talk about the hydrogen and the oxygen. Let's start, because A starts with nitrogen. Let's look at that first. One of the things you should understand if you look at this compound, it is an ionic compound. In other words, this compound could be broken down into NH4. What would be the charge on an NH4?
Plus.
That'd be a plus. And ClO4. And you might not recognize that immediately as an ion unless you think of perchloric acid, which would be HClO4. Obviously, we're losing a proton from perchloric acid. Must mean this ion has a -1 charge. Now we know we're going to look at the oxidation states of nitrogen and chlorine. In this case, one of the things we have to memorize is that the hydrogen in any bond or in any molecule, hydrogen is an oxidation state of what, John?
Of a +1, unless it's with a metal or it is H2.
Nice. So it almost always has +1. In this case, certainly has a +1. We've got 4 of them, so we've got a 4+ charge, or 4+ charge on the overall molecule here from the hydrogen, which must mean if we've got a net of 1+, the nitrogen is a 3-. The oxidation state of nitrogen in this compound is 3-. And if we look at the product over here of reaction 1, the product, we've got N2 in its most common elemental form. The oxidation state, by definition, is a 0. So the oxidation state of nitrogen is going from a -3, or 3-, to a 0. The oxidation state is increasing, which means by definition that this is an oxidation reaction. Nitrogen is being oxidized.
So that means B has to be wrong.
B has to be wrong. And then C and D really don't answer the question because those talk about hydrogen oxidation and oxygen reduction. And this one's talking about nitrogen. Let's just fill out the chlorine just so we make sure.
Yeah.
Okay. In this part of the molecule, we've got O. Oxygen almost always has a -2 oxidation state. There are 4 of them, meaning oxygen's contribution to this overall molecule is 8-. We've got a net of -1, which means chlorine's contribution here must be what, John?
+7.
+7. So we've got 7+ as the oxidation state of chlorine in reaction 1. But in the product here of reaction 1, where we see chlorine, we've got chlorine again in its most common elemental form. By definition, the oxidation state is 0. In this case, we're going from a +7 to a 0. We're diminishing or reducing oxidation state, which by definition is a reduction reaction. So A is definitely the right answer because nitrogen is being oxidized and chlorine is being reduced by this reaction. Let's look at question 8. Question 8 reads, which of the following is most likely the reason why fuel in a gaseous state is not used for rockets? Now, you might not know much about rocket science. You might be like me in that way. But you should understand one thing. When you see a rocket, if you see an image of a rocket on TV, you got the rocket, it looks like this. Typically, they don't have big balloons full of gas that slowly deflate over time, right? That's not how you see a rocket. Instead, when you see the rocket, if there's anything, there's these solid metal rocket boosters, but they're not balloons. What's going on? When you're shooting a rocket into space, you've got to minimize the volume of that rocket. And the best way to minimize the volume of the fuel is to put it in the most compact form you could. In this case, when we launch a rocket, we launch it with solid fuel if possible. Let's find the answer choice that's going to agree with that. Again, reading A, it says, which of the following is most likely the reason why fuel in a gaseous state is not used? Because we want to minimize volume. Which answer choice says that? B says, a substance has greater volume in the gas phase. You should understand that. That's simple science. Substances in gas phase occupy greater volume than they do in other phases in liquid or solid.
So question 8, really every answer choice is true in terms of science, but they're just asking us to use reason. So this is really not a science question. It's really a common sense question. Which should we care more about? If it has too much kinetic energy? No, that might be good for a rocket. Does it have too much volume? Well, that doesn't seem like it'd be very good, right? When you look at these astronauts, they're cramped together. You ever watch Apollo 13? They're cramped. They need space. So it seems a solid or a liquid fuel would be better than a gas fuel for that reason.
Good. And that's John's way of putting it. Me, when I see a question like that, what I do is I draw myself a ridiculous example, like a rocket with 2 big balloons on it. You wouldn't see it. Okay, let's look at question 9. And through the magic of television or video, I've erased all the information that we had up here before so I could get a little space for question 9. Reading it, it reads, a rocket ship of mass m is to be launched into space. Which expression gives the minimum kinetic energy required for the ship to escape Earth's gravitational field? Now, there's one thing I have to know immediately about kinetic energy, and that would be the formula for kinetic energy. That would be 1/2 mv squared. But I do not have to go into the MCAT, and you don't have to go into the MCAT knowing how much kinetic energy you need to escape Earth's gravitational field. In other words, when they ask us a question like this, information has to be given to us in the passage. If we look in the first paragraph, it says, in order to escape from the gravitational field of the Earth, in the first paragraph, a rocket must achieve a minimum escape speed given by the formula V is equal to the square root of 2 times g times r. Now we might then, if we started wondering what r was, we might start plugging in and trying to figure out what r was, but we can see, if we look at these two formula, that if we know velocity necessary, and we can plug that velocity into kinetic energy, we should be able to solve this problem without even knowing what r is. Let's do that. We've got to plug v in here, so we've got to square this. If we square this, we take the square root and then we square the square root. Essentially what we're going to get is 2 times g times r for velocity. In other words, the kinetic energy formula is now 1/2 times m times 2gr. The 2 and the 1/2 cancel. My new formula for kinetic energy necessary to escape Earth's gravitational field is m times g times r. Let's find the answer choice that says that.
Choice D.
Choice D.
All right.
Oh my God. That question was probably a lot easier than you thought it was when you took the test the other day. And I just want to point out the fact that you probably, if you feel that way, you probably fell into the trap of wondering what R was. You need to see, again, John and I have been saying it, simple science. Question 10. The function of the iron in the rocket fuel is to. Now, you might not know what iron does in rocket fuel. So again, it has to say something in the passage. In the bottom of the 4th paragraph, it explains that iron is also added as a catalyst. Now, one of the things you have to know about catalysts is that they increase the rate of reaction. Now, you might wonder, well, this question is saying the function of the iron in the rocket fuel is used to, okay, let's find one that says decrease the time of the reaction or increase the rate of the reaction. And when we're looking at it, we need to think about this formula. Power is equal to work per unit time. Because we know that formula, and this is a must-memorize formula for the MCAT, if you diminish the amount of time, you can do two things to increase power. You can increase work, or you can decrease time. If you increase the rate of reaction, it's the same thing as decreasing the time. So effectively, when you use a catalyst, you're increasing the rate of reaction, decreasing time. If you decrease time holding work constant, power increases. Question 11. As reaction 1 occurs, the ammonium perchlorate fuel is consumed in the rocket. As the reaction proceeds, the enthalpy change is. So we're looking for enthalpy change. Let's go put reaction 1 back up here and think about enthalpy change. As soon as we look at reaction 1, we see a product of reaction 1 is heat, meaning this reaction is what, John? Endo or
exothermic?
Exothermic. Delta H value has got to be?
Negative.
Negative by definition. We can eliminate immediately the answer choices C and D. Now we got to go on. It says entropy change. We've got A and B, and they're talking about entropy change. On the reactant side, we've got a solid. But on the product side, we've got a gas, a gas, a gas, and more gas. Wherever you've got more gases, you tend to have more entropy. In other words, delta S in this reaction is positive. You're creating more disorder in the universe by the progression of this reaction. Entropy is positive, making answer choice B correct.
So you're telling me when I'm looking for change in entropy, I can count the number of gas molecules on each side of the reaction, and the side with more gas molecules means more entropy.
That's what I'm telling you.
Great.
All right. Question 12. If the solid fuel reactions go to completion in the presence of excess aluminum, the molar quantity of aluminum oxide produced will be. Now, one of the things you have to do here is you probably looked at this question and you said, it's a hard problem, and it is. You got to look at the answer choices to get the whole picture of what's going on. We're comparing the product of aluminum oxide versus the product listed in all 4 answer choices, aluminum chloride. And we see those two products if we look at reactions 2 and 3. Reaction 2, the product is our aluminum oxide. Reaction 3, the product is our aluminum chloride. Now we move back and we look at the reactants that we're going to put in there. And we're saying, this question is saying, we've got excess aluminum. In other words, a lot of this and little of these. In other words, these two things, the oxygen and the chlorine gas, are going to be our limiting reagents. Those are the things we're going to run out of first in the progress of these two reactions. We go back and we look at reaction 1 then, which was our initial reaction. And we've got our ammonia perchlorate, that's the name of this compound here, going into reaction 1. And we're producing chlorine gas and oxygen gas. And these two gases are the same gases that we're then going to use up in these two reactions. What's interesting here is that we've got a 2-to-1 ratio. In other words, as this reaction proceeds, we produce 2 moles of oxygen for every 1 mole of chlorine gas that we produce. Right? So we're producing these in a 2-to-1 ratio. In other words, if these two gases are the limiting reagents, then the one of these reactions that ends first will be dictated by the one of these compounds that we have less of. We're producing twice as much of this as this. We've got less of this, so this reaction will stop first. In other words, in the end of this reaction, we're going to produce twice as much of this as this. Let's find the answer choice that says that.
That's choice C, twice the molar quantity of aluminum chloride.
Can I take off this ridiculous hat now? John? John? John?
Oh, what are you doing?
Looking for you.
Let's get started.
Okay.
I'm ready. Passage 3. Messing around all the time. Okay. Passage 3. Question 13. If the mass spectrometer is configured exactly as shown in Figure 1, it can be used for. Now, this question is getting at the fact that a charged particle moving through a magnetic field will experience a force, and that the direction of that force is dependent upon right-hand rule. So if we take a look at our Figure 1 here, for right-hand rule, we're going to point our thumb in the direction of the moving positively charged particle. Let's assume it's positive for a moment and see if that works. So our thumb goes in the direction of the particle moving. Fingers go in the direction of the magnetic field, which is into the board in this case. Those X's mean it's going that way. Those are like the ends of arrows. So thumb up, fingers in the board, and as it enters the magnetic field, the palm pushes on the particle. So it's pushing this way, and that's going to move it this way. So this must be a positively charged particle. For a negatively charged particle, it would move in the other direction. A neutral particle would just move straight. Answer choice then is A, positively charged particles only. Question 14. Which of the following expressions is equal to the speed of an ion as it moves through the magnetic field of the mass spectrometer? Jordan, you want to take this one?
No, I'm scared of this one.
This one looks scary, but it's actually not so tough. The first instinct is, oh, look at this. Let's see if they've got a formula. Let's try and do some algebra. You don't have to do that. And why not? If you look at the answer choices, the variables all end up creating different units. So if you see what I mean, we have voltage, and a volt is really a joule per coulomb. A joule per coulomb is a kilogram meter squared per second squared per coulomb. Now, how did I get kilogram meter squared per second squared? If you didn't know that's what a joule is, how much you get that?
Well, you might think about an energy formula, for example. Kinetic energy, 1/2 mv squared.
Exactly, 1/2 mv squared, where m is kilograms and v is meters per second squared. And then you have the units of joules. All right, we also have, we're looking at the answer choices, we have Q, and Q is in units of coulombs. Then we have M, and M is in units of kilograms. What units do we want for this question?
We want meters per second because we're looking for the speed of an ion.
Exactly. So we know the answer has to have meters per second. Where do we have meters per second? In the volts units up here. So we know that's in the numerator. Kilogram meters squared per second squared per coulomb. And then we want to get rid of this kilogram. So we'll divide. Let me just write this formula over here. We put voltage on the top. We're going to get rid of this kilogram, we're going to divide by kilograms here. So we know that M's going on the bottom. And then we still have this coulomb. We want to get rid of that coulomb. So we're going to multiply by Q to get rid of the coulomb. Okay? Now we have meters squared per second squared. How do we fix that?
I got to take the square root.
Yep, we're just going to take the square root there. And we end up with answer choice D. Much easier in this case to solve it by units. The way I knew how was I looked at the answer choices and I recognized each one of these answer choices is going to have different units. MCAT's going to do that to you sometimes. This is a much easier way to solve it than doing the algebra from the formula and trying to make sense of the whole thing.
John, my book has a 2 in answer choice D for question 14.
Oh, you're right. I guess I made a little mistake. But wait, I still know it's answer choice D, don't I?
Sure, because that's the only one where the units would come out right.
Exactly. That 2 is a constant. It has no units. So you see there, even though when I solve it with units, I can even make that mistake, that mathematical error, and still get the right answer. That's why it's a better way to solve it. Question 15. 4 particles are launched into the mass spectrometer. The masses and charges of the particles are shown in the table. Which of the particles will reach the detector at the greatest value of R? If we take a look at the spectrometer here, we see R is the radius of this circle here. They've given us the table, and the table compares masses and charges. So let's see how charge would affect it. The value of the charge here, if the charge were greater, what would that do to the radius?
Well, I'm thinking about the formula for the force in a magnetic field. F is equal to QVB sine theta. If I increase Q, the charge, I'm going to increase the force. If I increase the force, I would tighten or decrease the size of R.
Right, so what you're saying is as Q goes up, F also goes up, and F is the force on the charge that's causing it to make that turn. So as Q goes up, we're going to decrease R. So we're looking for a low value of Q. If we look, Q is charge, and if we look on the table there, the low values are particles 1 and 3. 1 and 3 have a different mass. Now, how would increasing the mass change this curve?
Well, we still have a force working on it, and from Newton's second law, F equals mass times acceleration, that might have something to do with it.
Exactly. If we increase the mass, the force necessary to turn the particle is going to be greater. So a greater mass really is going to have a greater momentum and tend to go straighter. If you think about it, it's just like throwing a ping pong ball in the wind versus throwing a golf ball in the wind. If I've got a crosswind, when I throw that ping pong ball, that same force is going to push that ball over and make it curve, where the golf ball is not going to be affected by the wind. So the greater mass means a larger R. And we said that a smaller Q actually is going to be a larger R. So here we see particle 3 has the smaller charge and the greater mass. So answer choice is C. Question 16. A technician is designing a mass spectrometer. Because space is limited in the laboratory where the spectrometer will be used, the technician is attempting to make the device as small as possible by decreasing the radius of motion of each measured particle. This goal can be achieved by. So this is similar to question 15 where we want to decrease this radius. Only now they're looking at different variables. The variables they're looking at are V for voltage. Over here, this V is velocity, not voltage. So we need a different formula. And then also B for the magnetic field. Thank you, Jordan.
You got it.
Okay, so if we go back to the passage and we look at the formula is Q over M equals 2V
B squared R squared.
over B squared R squared. So they want to know what happens to, we decrease this radius. So they want the radius to go down. Well, if B goes up, the radius goes down, right? They're inversely proportional to each other. And if V then goes down, because it's in the numerator, radius will also go down. So we want B to go up and V to go down. Answer choice is D, decreasing V and increasing B.
On this question, John, this is an interesting representation of something we've been referring to. Simple science, right? All they want you to understand is proportionalities on this particular problem. They want you to understand the relationship. If two things appear on the same side of the fraction, in other words, B and R are both on the bottom side of this fraction, you need to understand that they have an inverse relationship. As one goes up, the other goes down. Conversely, if they're on opposite sides of a fraction, as V and R are in this case, they want you to understand that there's a direct relationship. The exponents add a little bit of complexity to it, but MCAT wants you to understand that. And they're not just going to ask you, are these two variables inversely or directly related? Instead, they'll disguise it in a little bit more complex-looking science. That's what's going on there, I think.
Right. Question 17. A mass spectrometer can be converted into a velocity selector by moving the detector and adding an electric field. The electric field must be aligned so that its effect on the charged particle will oppose the effects of the magnetic field. Which of the following diagrams shows the proper alignment of the electric field for a velocity selector? It's kind of a complicated question, but all they're really saying is, here, the magnetic field turns the particle to the left. We want to set up, and we said before from the other question, this was a positively charged particle. So we want to set up an electric field to push the particle to the right. And actually, the two will counteract each other and make the particle go straight. So we don't care about this velocity selector thing. We just want to understand that the magnetic field should push it one way and the electric field should push it the other way. So we want the electric field to push this way. Now, if you take a look at the answer choices, you notice they have left the magnetic field all going in. So the magnetic field on the velocity selector is pushing it to the right, to the left. So we want the electric field to push it to the right. How do we set up that electric field? These arrows represent the direction of the electric field. If it's a positively charged particle, in an electric field, a positively charged particle goes from the positive charge to the negative. So it goes with the electric field. So we want the electric field to point in the direction that it will push the positively charged particle. If we take a look, that's answer choice B. The electric field lines are pushing this way, and so the magnetic field will try to turn it this way, the electric field this way. It'll end up going straight. Question 18. When the value of R is doubled, the work done by the magnetic field on the charged particle will be. This is kind of a trick question in a way. They're saying they're going to double the value of R. So they want to increase, let me move this for you. They're saying they're going to do something to the spectrometer where R is going to double. What will the work be that's done on the particle then as it turns? Now, what you want to understand is that a magnetic field does no work on a charged particle as it moves through that magnetic field. The reason is the force is perpendicular at all times to the direction of motion of that particle. A force that's perpendicular to motion cannot do work on the particle. In other words, it doesn't change the velocity, it only turns it. If it doesn't change the velocity, doesn't change the kinetic energy, no work is done. Answer choice here is D. So we're on passage 4. Passage 4 is about light. Are you ready, Jordan?
Oh, I'm sorry, John. Just practicing diffraction experiments, man. You know, if you make a really small hole with your fingers and then you look through at a source of light, you can actually see diffraction going on.
That's a diffraction experiment?
Okay.
Let's start the passage, okay? Okay, so passage 4, question 19. Doping is used in photography because an undoped sample of silver bromide crystal absorbs photons only from which part of the electromagnetic spectrum? So if we take a look here, and we're going to use this formula here, energy equals HF. Now we're going to take a look at figure 1. And in figure 1, we see the undoped portion is this line right here, pure AGBR. These other lines are the doping. We're going to put Te2 minus, Se2 minus, S2 minus. We dope AGBR with these 3 lines here, with those 3 compounds or atoms. So this is the undoped, and the undoped has a wavelength that's low. And if we've got a low wavelength, remember from C equals frequency times wavelength, that frequency is going to equal C over lambda. So we'll plug C over lambda in this equation. E equals H C over lambda. So as lambda goes down, energy goes up. Answer choice D, high energy. Question 20. A film company is producing a specialty film that is highly sensitive to orange light. The company should increase the quantity of which ion in the crystal? Okay, if we take a look at our table 1, we see that orange light is 590 to 630 nanometers. Then if we take a look at figure 1, we see the wavelength will be from 590 to 630. So about right there. Now if we look at that, on this graph, 590 to 630, which doping compound does this correspond to, or doping ion? And it's mainly Te2 minus. Answer choice is D.
Okay, so you're saying that when you've got Te2 minus in the crystal, that the AGBR absorbs more light.
That's correct. 21. Which of the following statements is true regarding the bromide ion and elemental krypton? Well, let's take a look. The bromide ion and elemental krypton, they have similar chemical behavior. Would that be true? How do I know that's not true?
Because that's just ridiculous. I mean, krypton is a noble gas. It's not very reactive.
Right, and for chemical behavior, what am I really looking at in terms of periodic table?
Things in the same group.
Exactly. We're looking at the same group or same family for similar chemical behavior. And so A is wrong. How about they have the same charge?
Can't be right either. Krypton is a noble gas. It's not going to have
One's an ion, and one of them is elemental krypton. Elemental krypton is neutral, and bromide ion is a negative charge. And how about they are isoelectronic?
Iso means same.
Iso is the same. Electronic is electrons, so they have the same number of electrons. If I take a look at the periodic table, I'm going to see that the bromide ion is going to have a charge of -1. That's the charge on a bromide ion. And that means that it's going to have 1 more electron than neutral bromine. And that's the same number of electrons as krypton. So C is my answer. Answer D is their isotopes. Are they isotopes?
No. No,
because isotopes are...
Same element, different number of...
Exactly. They'd have to be both krypton or both bromine to be isotopes. Okay, let's go on to number 22. A light wave has a frequency of 5 times 10 to the 14th hertz. What color will this light appear? So here we have hertz, which is frequency, and then we also know C. So we can use this formula. We should know this by heart, right? C is the speed of light, which is 3 times 10 to the 8th meters per second. The frequency they give in the question is 5 times 10 to the 14th. And then we solve for wavelength. And then we'll check wavelength against our table 1. So here we have 3/5 times 10 to the 8th divided by 10 to the 14th equals my wavelength. So 3/5 is 0.6 times 10 to the, and then I have 8 minus 14, so that's a 10 to the -6th. We're going to multiply by 10 here, so we'll divide by 10 here, so I end up with 6 times 10 to the -7th equals lambda. Over here on my chart, notice I'm in nanometers. Nanometers are 10 to the -9th. So if I want to change this to -9, I'll divide by 100. That means I need to multiply this by 100. So I have 600 times 10 to the negative 9th wavelength. 600 gives me orange light. Orange light is answer choice C. Question 23. Photonegatives are treated with a fixer, which removes unreacted AGBR from the gel. If a negative is not treated with a fixer, which of the following will occur? You want to take this one?
Sure. This is really a reading comprehension question wrapped up in the middle of our physics section. Let's look at the passage and do a little reading comprehension. First paragraph, it says, when a crystal of AGBR is exposed to light, a photochemical reaction causes some of the silver and bromide ions in the AGBR, in the crystal, in other words, to be converted to their elemental states. In other words, become solid silver. Okay. In this question, it says the fixer removes unreacted AGBR. In other words, it's going to remove any ion or any crystal that hasn't reacted. In other words, none of it can become solid silver. The second paragraph then says, to produce a photographic negative, a sheet covered with a gel containing AGBR crystals is exposed to light. As light photons are absorbed by the crystals, elemental silver is produced. In other words, elemental silver appears darker than the silver ions, so the negative appears gray or black. Let's look at the answer choices and find the one that says what would happen if we didn't remove the AG so it couldn't go to solid silver. C says the negative will gradually turn black when exposed to light. Obviously, if the function of AGBR is to absorb light photons and then become elemental silver, which is black, if you don't remove the AGBR crystals, the reaction will continue and eventually the photographic image or the negative will turn black.
Good.
All right, we're looking at the first set of freestanding questions. Question 24 reads, a chamber at constant temperature contains equal masses of neon and argon gases. Which of the following is true regarding the two gases in this chamber? Now, this is kind of an interesting problem because most people probably look at that and they start thinking, well, the mass is a really important part of this overall question. The fact is, it's not. The thing that you have to know about any two gases is, if they're at the same temperature, their kinetic energies, their average kinetic energies are the same. Remember, for gases, kinetic energy is directly proportional to temperature. As you increase the temperature of a gas, you increase its kinetic energy. Let's find the answer choice that says that. D says exactly that. The average kinetic energy of the argon atoms is equal to the average kinetic energy of the neon atoms. There may be one little gas molecule or 100 gas molecules in there that have more, but the average kinetic energy is the same in both gases.
Right, so once again on question 24, what we have to do is we're looking for the simple science first. Look for the easiest way to answer the question before you look for the hard way.
Question 25. A chemical process occurs spontaneously at a temperature of 500 kelvins. When the temperature is reduced to 250 kelvins, the reaction is no longer spontaneous. Which of the following must be true about the process? Okay, well, let's look at Gibbs' formula. Delta G is equal to delta H minus T times delta S. And the thing about this formula, well, there's a couple things, but one thing you have to remember about this formula is we're looking for a negative value of delta G for a spontaneous reaction. In other words, if you have a negative value for delta G, the reaction is spontaneous. And you have to be aware of, I don't think you have to memorize them, but you have to be able to figure out all the possible scenarios that might result in your having a negative or a positive value for delta G. So let's look at it. Obviously, if you have a negative value for delta H, that would tend to be in support of a negative value for delta G. And if you had a positive value of delta S, that would make this whole part of the equation, a positive times a negative, would make this whole part a negative and a negative will give us a negative. So this is a negative and a positive would give us a spontaneous reaction. The second circumstance might be if we had a negative value here for delta H, but a negative value for entropy. If entropy is decreasing, let's see how that impacts us. The temperature times the negative value here will wind up in a positive value for this overall thing. So this reaction will be spontaneous at low temperature. In other words, at high temperature, these negatives will combine and give you a really big positive number. It will overcome this negative. So spontaneous, and then I'm going to put parenthetically low temperatures. Next possible scenario, you've got a positive value for delta H. Now you've got a positive value for entropy. A positive delta H would be an endothermic reaction, a reaction where we have to put heat in, and a positive delta S means entropy is increasing. When is this reaction spontaneous? this positive times this negative is going to give us a large enough negative for this part of the equation to overcome this positive at high temperatures. So spontaneous high temps. And then finally, if we have a positive value for here and a negative value for here, this would give a positive value of enthalpy, and this would be a negative value for entropy times a negative T. These would combine here to give us a positive for this overall part of the equation. This set will be non-spontaneous because they will sum to give us a positive value for delta G. Let's find the answer choice then that agrees with our understanding. A says entropy decreases during the process. So we have a decrease in entropy here and here. This would be non-spontaneous. At low temperatures, this reaction will be spontaneous only. No, the reaction was spontaneous at high temperatures. A can't be right. B says the Gibbs free energy change for the reaction is always positive. Well, we came up with a couple of circumstances, and in this case, it was spontaneous. Delta G can't be positive. B is out. C says the process never comes to equilibrium. John, what does that mean?
All processes come to equilibrium. So.
At some point. So that probably is not the right answer. Let's just look at D. D says the process is endothermic. It's endothermic. Let's see. It's spontaneous at high temperature, but it's non-spontaneous at low temperature. And the trick to this is this looks like high temperature, and this looks like high temperature too, but it's not. 250 Kelvin is actually below 0 degrees Celsius. This reaction occurs and is spontaneous at high temperature when there's enough energy available to heat it and to get the reaction to go. It's an endothermic process. 25 is D. 26. A 1 molar aqueous solution of which of the following salts will have the lowest boiling point? For this, we got to know our colligative property formula for the freezing point, the boiling point elevation. Luckily, they're both the same formula, really. Freezing point depression, boiling point elevation. The names of the variables change a little bit, but you must know this formula. We're looking for the change in temperature based on these variables. This K is a constant based on the solvent. This is an aqueous solution, so the solvent is a constant value for water. The molality of each of these answer choices is the same. It says in the question we have a 1 molar solution. These two values are constant. The only thing that changes is the I, the Van 't Hoff factor. One of these ions...
So you're saying that A, B, and D break up into 3 particles, and C breaks up into 2, so that makes C the answer choice.
C is the right answer because this value would be the lowest, making the boiling point elevation for C the smallest. Good. Let's look at 27. What is the ground state electron configuration of a neutral phosphorus atom? We've got to go refer to our periodic table. We'll see phosphorus. It's in the 1, 2, 3, 4, 5th column. That's going to be, and you should be able to do this. This is a pretty simple problem, frankly, and you need to be able to do it. This is going to be 3s2, 3p3 as the last units there. Of course, you've got to start with 1s2, 2s2, 2p6. Best answer here, B.
What are you doing?
Oh, thank God you're here, man. I just calculated that the atmospheric pressure is 10,000 kilograms per square meter. I need your help holding up the atmosphere.
You're unbelievable. It is 10,000 kilograms per square meter, but it's pressure. You don't have to hold it up. It doesn't have any direction.
Huh.
You must have been working on passage 5.
Yeah.
Okay.
I'm glad
Let's do passage 5.
Okay.
Passage 5, number 28. The peak of Mount Everest, the tallest mountain on Earth, is 8.9 kilograms above sea level. If the temperature of the peak is 0 degrees Celsius, approximately how many normal breaths must a mountaineer take at the peak to bring in the same amount of oxygen taken in with one breath at sea level? This looks like a pretty complicated equation. But if we take a look, and they're comparing 8.9 kilograms, so kilometers. Let's compare, so that's on the chart, that's 9,000, so 9,000 meters, approximately. So if we take a look at the pressure, it's 243 at 9,000 meters. And at sea level, it's 760. You need to see that this is a ratio of about 3 to 1. So in terms of pressure, if we took a look at this formula, which you all know, PV equals nRT, and we compare pressure and number of moles. The more moles we have, the more pressure we have. They're proportional. So at sea level, we have 3 times the pressure, 3 times the number of moles. So how many breaths are we going to have to take in?
Well, it sounds to me like we'd have to take 3 times as many if we got to oxygenate those tissues.
Right. Answer choice B. Question 29. Which of the following diagrams best shows the change in atmospheric pressure with increasing altitude? Now, what we've done, or Jordan has taken the liberty of putting in the difference between every 1,000 meters. And you can see here from 0 to 1,000, the change in pressure is 91. Whereas down here from 8,000 to 9,000, the change in pressure is only 38. So we see it goes lower. So it didn't help us much because in the diagram, all 4 went lower. Would everybody agree this is ridiculous? Jordan, would you agree?
I'd
the
agree.
stair-step function is ridiculous. And it doesn't correlate with our results. But what we need to see now is it linear? Is it exponentially this way or this way? If we take a look in the middle then, remember we went here, it's 90, and here it's 38. In the middle, it's 60. So the pressure is getting less and less. Answer choice D. It's not linear, it is D. Question number 30. What is the density of air at STP? Now, if we take a look, they told us the molar mass of air is 29 grams per mole. And I want the density. What units? Again, you'll see me, I'm coming back to units, because before I start thinking of formulas or anything else, or as soon as I'm stumped by formulas at least, I start thinking about units. What is density? What kind of units is density?
Mass per volume.
Mass per unit volume. So we're going to be in grams. Let's just leave it here. Per, and a unit of volume would be liter. So what do I need to multiply this by to get to this?
Well, you need to get rid of moles.
I need to get rid of the moles, and I need to add liters. Moles per liter. So if I only knew at STP a number for moles per liter.
Well, any gas occupies 22.4 liters of volume. Any 1 mole of that gas occupies 22.4 liters at STP.
So I know liters per mole. So I'll just take liters per mole, which is 22.4, and I invert it, right? So it's 1 mole per 22.4 liters. So grams per mole should be 29 over 22.4. That looks to me like a little bit over 1. Let's see if we've got an answer choice. Answer choice A.
God, that seemed like such a hard problem when I first looked at it.
Right, and sometimes when you just look at units, it's really going to simplify the problem. So always when you're doing an MCAT problem, look for the easiest way to do it first and work your way up. If you can't do it the easiest way, try the next easiest way and work your way up. Do the hardest way last. Question 31. A balloon with a volume of 10 liters was released at sea level at a temperature of 25 degrees Celsius. The balloon rose to a height of 2,000 meters. If the temperature decreases by 10 degrees Celsius for each 1,000 meter rise in altitude, which of the expressions below gives the volume of the balloon in liters at 2,000 meter altitude? All right, if we take a look at the answer choices, A and B, they left the temperature in Celsius. C and D, they put it into kelvins. We're actually going to use PV equals nRT here, where R is going to be in kelvins. Whenever we use PV equals nRT, we're going to use kelvins. And remember, in chemistry, kelvins is always better to use. So A and B can go out immediately. Now, how do we use PV equals nRT? They're changing PV and T, so let's bring them over to this side of the equation because N and R will stay constant. So we have P1, V1, and T1 is going to equal NR, the constant, or in other words, any PVT, or PV over T will equal any other PV over T. So we have P2, V2 over T2. Now we're going to solve for the final volume. That's what the question asks us to solve for. And we get P1 over P2 times T2 over T1 times V1 equals V2. So if we take a look and see T2, the final temperature is decreasing, so the final temperature is going to be 278, and the initial temperature is then 298. We take a look at the pressure. The final pressure is going to be 760.
The
initial pressure is 760, and the final pressure is 593. The pressure is decreasing. The initial volume is 10. So we get this answer choice, which is
C.
Choice C. Question 32. The surface area of an adult male is approximately 2 square meters. What is the magnitude of the force exerted on an adult male by the atmosphere at sea level at 0 degrees Celsius? Now, this is what Jordan was getting at when he's holding up the atmosphere. If we have pressure, pressure is really the definition of pressure. 3 lines denotes definition, is force over area. So we can actually set the pressure, 1 atmosphere, equal to the weight of the atmosphere over the area over which that weight is exerted. Now, the thing here is atmosphere is not an SI unit, so I want to switch to SI units. What is 1 atmosphere of pressure in pascals?
10 to the 5th Pascal.
Yeah, it's approximately 10 to the 5th. So stay with me. I'm going to take this and bring it over here. Instead of 1 atmosphere, I say 10 to the 5th pascals equals then the weight mg over the area, which is 2. And the question gives me 2 square meters. So 2 times 10 to the 5th gives me the weight or the magnitude of the force exerted on an adult by the atmosphere at sea level. Or answer choice D, 200,000 newtons.
And that sounds like even more than I thought it was.
Question 33. What is the partial pressure due to oxygen gas at a height of 3,000 meters above sea level? All right, so what we're going to use here is the pressure, the total pressure, times the mole fraction equals the partial pressure, or Dalton's law. So partial pressure of some gas, in this case oxygen, equals the total pressure, the pressure of the air, times the mole fraction of oxygen. All right, so they said at 3,000 meters, we'll go to the chart. At 3,000 meters, we've got 524 is my total pressure. And then my mole fraction, where can I get mole fraction of oxygen?
Well, that'd be tough unless we thought about the fact that we should know 20% of the atmosphere is oxygen.
Exactly. So we've got 21%, or 0.21, and 20, we'll round it off to 20, is going to be oxygen. The rest is going to be nitrogen, and then a tiny little bit will be other gases. So we end up with a 0.21 times 524, which is going to be about right around 100, and we have answer choice A. Question 34. When placed in boiling water at sea level, an egg will become hard-boiled in 3 minutes. At 3,000 meters above sea level, what will happen? Well, if we take a look at sea level and 3,000 meters above sea level, there's a difference in pressure. As we get a higher altitude, we get a lower pressure. Now, a liquid boils when vapor pressure equals atmospheric pressure. So at a high pressure, we need a high vapor pressure to make a liquid boil. Vapor pressure is a function of temperature. So the temperature needs to be high when we have a high pressure or a low altitude. The water will boil at a low temperature when we have a high altitude, low pressure. So here, if we take a look at the answer choices, we see that choice B, the water will boil at a lower temperature and the egg will take more than 3 minutes to become hard-boiled, would be the correct answer. Because if the water's going to boil sooner and the temperature won't get as high, so it'll take longer for the egg to boil.
All right, we're working on passage 6, and we'll start right away with question 35. It says the pH of a swimming pool is normally kept near neutral. Which of the following would be least effective in generating hypochlorous acid when added to a pool with a pH of 3? So there's a bunch of hints and a bunch of things going on in a passage here, and we can jump right on it. If we know the structure of hypochlorous acid is a product in this reaction, which is described in the passage as reaction 2, hypochlorous acid here is a product. And the question is, which would be least effective of the answer choices listed, which would be least effective in generating that? So it seems that if we added chlorine, we could generate this product. But we've got a pool, not at neutral, but with a pH of 3. And of course, if the pH is 3, John, what does that mean?
A lot of protons.
A lot of
H+.
protons around. We've got acidic condition. I probably don't want to swim in this pool, or you don't either. So we got a lot of these around, and Le Chatelier will tell us that if we increase the concentration of these at equilibrium, it'll push the equilibrium this way. So if we put chlorine gas in here, it will not be very effective at generating this acid because of the conditions in the pool. So the best answer here for 35 is going to be answer choice A, chlorine gas. Question 36. Which of the following expressions is equal to the solubility product for calcium hydroxide? Of course, what we have here is we have to know we can drop calcium hydroxide, which will be a salt, into solution, and it will dissociate into the calcium ion, 2+, and 2 hydroxide ions. 2 hydroxide ions. And when we express, or we write the solubility product expression, it will be KSP is equal to, as always, molar concentration of the products only, because over here, John, what form of
That's a pure solid, and we don't include pure solids or pure liquids in the KSP.
Excellent. So KSP, we only look at the products here. The products would be calcium ion, Ca2+. We put the square brackets around to indicate molar concentration, and we get the hydroxide ion. And because we have a 2 here as a coefficient in this expression, we need to put an exponent of 2 above it. Our KSP then for this salt dissociation is answer choice
D.
D. Question 37. A swimming pool has been treated with hypochlorous acid so that the concentration of hypochlorous acid is 0.1 molar and the concentration of hypochlorite ion is 0.01 molar. What will be the pH of the water in the pool? So we've seen some questions like this one, and essentially what we can use to help us solve this particular problem is an application of the Henderson-Hasselbalch.
And that's because you have to recognize hypochlorous acid and the hypochlorite ion are an acid with its conjugate base.
Good. So let's plug in what we know. We know the Henderson-Hasselbalch equation is pH equals pKa plus the log of the A minus concentration, in other words, the conjugate base concentration over the HA concentration, or the acid concentration. Good, so this is Henderson-Hasselbalch, not necessarily must memorize for MCAT, but you definitely you need to be able to know how to plug into it and sort of manipulate it a little. So let's plug in or see what we're looking for and what we can already plug in. We're looking for the pH. So the question is asking here for the pH. We're given somewhere here in the passage the pKa.
It's the second paragraph at the top. The acid dissociation constant for HClO is 3 × 10⁸.
And the pKa,
and the pKa is 7.5.
The pKa is 7.5. So we're looking for the pH. We know that the pKa is 7.5, and they tell us in the question that the concentration of hypochlorous acid, that will be our acid concentration here, is 0.01 molar.
No,
0.1 molar, or 1 × 10⁻⁻⁻1. And so we're going to do plus log. And again, in the question, it tells us the concentration of the hypochlorite ion, the conjugate base here, is 0.01 molar, or 1 × 10⁻².
2. That bottom was 10⁻⁻1 there.
You got to include everything, right? So what we have here is a 10-to-1 ratio, with this value being 10 times as many as that. So this is 1/10, or the log that we're looking for is the log of 1 × 10⁻⁻1. And the log of 1 × 10⁻⁻1, John,
is -1.
Is -1. So our formula now to calculate the pH is equal to 7.5 plus the log of 1 × 10⁻⁻1 is -1. 7.5 minus 1 is 6.5. The pH must be B, 6.5. 38. The chlorine content of a swimming pool has been measured at 7.1 parts per million. What is the chlorine concentration in the water? Oh my God, 7.1 parts per million. I don't remember seeing this. In the last sentence, it gives us a clue as to how to answer the question. The last sentence says 1 part per million is 1 gram of chlorine per 10⁶ grams of water, right? So 1 part per million equals 1 gram per 10⁶ grams of water. And 10⁶ grams of water is going to be 10⁻³ kilograms. Let me just clean up here so we can have something to work on. But we're not working with 1 gram or 1 part per million. We're working with 7 parts per million. So we're actually going to have 7 grams of chlorine in 10⁶ grams of water. So let's do a little conversion here. What we're looking for, and what is the chlorine concentration? So the question is asking, what is the concentration? And that would obviously be in molarity. And the concentration, or molarity, that's the number of moles of what we're looking for, moles over liters of solution. So we got 7 grams. First thing we have to do is convert that to moles. We need to multiply this. Let's see. We've got molecular weight of chlorine is going to be 1 mole per 72. I'm just going to round it to 70 grams. That's going to cancel out my grams, and what I'm going to have is 7 over 70, or 0.1 mole is the number of moles of chlorine that I have in 7 parts per million. And 10 to the 6th is, as we said, 10 to the 3rd kilograms, and of course 1 kilogram of water, John, is how much?
1 kilogram of water?
Yes, is how much in terms of volume?
Is a liter.
Is a liter. So this would be 10 to the 3rd liters of solution. So we have 0.1 over 10 to the 3rd, or doing the math, this is might also be expressed as 1 times 10 to the minus 1, divided by 10 to the 3rd, this would be 1 times 10 to the minus 4 is the concentration. That would be answer choice A for 38.
Right. So what this problem was is really, it's fairly simple. It's a unit conversion problem, but you have to realize that the parts per million actually means grams of chlorine over grams of water.
Great. 39, reaction 3 is an example of what kind of reaction? And I'll go ahead and draw reaction 3 up here very quickly. CO.
Yeah, now 39 is a problem that you just have to memorize. You have to memorize the single displacement or double displacement combination. This is in the book. So for reaction 3, as Jordan writes it up there, we can see that reaction 3 is a double displacement or replacement. Replacement and displacement are the same thing.
Right. Here we're splitting this compound right here, and we're taking the ClO and putting it here. And we are taking the calcium and putting it here. We're also splitting this compound into H and OH. We're taking the H and putting it here. We're taking the OH and putting it here.
Yeah, that's the tricky part about this problem is they use water as part of the double displacement.
So the best answer for 39, or the only answer for 39, is B. It's a double replacement reaction. Come on, wake up! Wake up! Wake up! Wake up!
What are you doing?
Oh, my foot fell asleep. I'm trying to wake it up.
And here's something else. Here, let's do passage 7. All right, passage 7. Okay, passage 7, number 40. Which of the pictures below shows the direction of airflow in the prairie dog burrow? Now we have this prairie dog burrow here, and it's got this little hill right there, right? And then over here it's got the opening. So let's see if we can just draw this here. Basically looks like this. Now the whole point here, if you look at the diagram, you've got the air coming up and over, and that's what this mound does. It forces this air to blow over like that, whereas this air can go straight over. And so what happens is, in the same amount of time that this air goes from here to here, this air goes from here to here. This is a greater distance. So the velocity is greater over here, and I believe that's V1 has greater velocity than V2. And since V1 has greater velocity than V2, we know that the higher the velocity, the lower the pressure. And what formula do we know that from?
We could use Bernoulli.
We'll use Bernoulli's equation, and Bernoulli's equation says that the following three things are equal to a constant. Pressure plus rho GH plus 1/2 rho V squared. And then we also have to look at, well, what we see here is that as V goes up, this stays the same. H is relatively the same. This distance and height, you see this a little higher than this one? That really doesn't make much difference. When we talk about height, and especially with a gas, we've got to have a huge height. So this doesn't really make any difference. In fact, did they give us that formula? They gave us, equation 1 is a derivation of this formula without that. So as V goes up, P goes down, because K is a constant. So V1 is greater than V2, so pressure is going to go from high pressure to low pressure, and we get current, and then the prairie dog gets air conditioning.
I wonder if they have like a PhD in physics for prairie dogs.
Maybe.
They should.
Question 41. The volume flow of the air is greatest at which point? Now if we take a look at this, we've got A is a little compartment here. Let me redraw this quickly. We have A is a little compartment, and B is a larger
C
compartment.
is the larger compartment.
I'm sorry, it's C right there. And we've got B at right here. Okay. All right. And we know from the continuity equation that the cross-sectional area of a conduit, this is our pipe or our conduit here, times the velocity of the fluid equals a constant. So in other words, Q is the same at A, B, and C. A is not the same. A is greatest at C. So if A is greatest at C, V is the lowest at C. So answer choice here, the volume flow rate of the air is greatest at which point? Q is the volume flow rate. It's a constant at all points. Answer choice D. If the air speeds at the different points in the burrow are represented by VA, VB, and VC, which of the following is true? Well, we really just answered that question. The airspeed is going to be the greatest at B, then A, then C. Answer choice here is going to be C. If the burrow has a circular cross-sectional area at point B with a diameter D, which of the following expressions is equal to the mass of airflow past point B each second? All right, for this we're going to really use the equation. It's similar to this continuity equation, but this is volume flow rate. And if we have volume flow rate and we want mass, let's say we have volume and we want mass, we can just multiply by mass per volume, and we'll get mass, and that'll give us a mass flow rate. So volume flow rate is given by Q, mass per unit volume is rho, and that'll give us what I'll call I, our mass flow rate. Okay, so I then is equal to density times area times velocity. If we take a look here, the area they've given us diameter. So if we want diameter, we really have to take, the cross-sectional area of a pipe is going to be pi r squared. So if we have diameter, we've got to take r and divide it by 2. So the cross-sectional area equals pi r squared, but we don't have r, we have d, so it's going to be pi d over 2 squared. So we'll plug this into our formula here, and we get I equals r d squared over 4 times v, and I don't want to forget my pi here as well. And see which answer choice that is? This is answer choice A. Question 44. A spoiler is a horizontal bar attached across the back of a sports car to increase traction. The spoiler does this by using the motion of the air to create downward pressure. Which of the following cross-sectional areas of a spoiler would create the most traction? So if we take a look at the spoiler, the answer I'm just going to tell you up front here is answer choice A. And if we take a look at that spoiler, and we see, let's look at an air molecule here and here. This air molecule moves along the top, velocity v1. This air molecule moves along the bottom, velocity v2. They're going to end up at this point at the same time. They start out at the same time, they end up at the same time. So which one's going faster?
V2's got to go farther.
V2, exactly. It's got to be much faster. If V2 is faster, that means V is greater. Remember, we're going to ignore this term because difference in height is very, very little here. So V is greater. That means P must be less. So here we have little pressure arrows. And up here, we have bigger pressure arrows because pressure is greater here. That pushes the back of the car down, increasing traction. Answer choice A for number 44. Question 45. The atmospheric pressure changes slightly from day to day based on the meteorological conditions. If the atmospheric pressure increases by 2%, the speed of the air through the burrow will. Well, let's take a look. If we increase the atmospheric pressure, what are we going to do here? If this was 760 and this is 758, we've got a difference in pressure of 2. And if we increased it and made this, I'm sorry, I missed,
758
let's call this backwards. Yeah, 758 and this is 760, a difference in 2. If we increase the overall atmospheric pressure, it wouldn't really change anything because we'd have 800 and 802, for example. So the difference in pressure is what's important here, not the overall pressure. Answer choice is D. It would remain unchanged. What are you doing?
Oh, it's a mechanics passage, man. I walked down the stairs.
No, let me show you. Let me show you. It's an elevator passage. Going up?
Okay.
Yeah, all right.
I think you're up on this
Why
one.
don't I do this one?
Okay.
Okay, passage 8. Question 46. If there is no friction on the elevator or cable, what is the work done on the elevator over the course of stage 1? All right, so this can be a little bit involved, a little bit tough, but basically if there's no friction, what we're really looking at is work done, and work done is going to be the change in mechanical energy, which is mgh, potential energy, plus 1/2 mv squared. All right, and that will be my work done. Now, what I would do, we're looking at just stage 1. What I would do is what you learned in the Examkrackers book, the way to solve this. We've got an elevator rising at 2 meters per second squared. That means its velocity is changing by 2 meters per second each second. And it does this for 3 seconds. So it starts at 0. If I look at a VT graph here, right? It's starting at 0, and it's increasing its velocity for 3 seconds, and every second that velocity increases by 2 meters per second. So its final velocity is 6. Average velocity then is 3 times the 3 seconds gives me 9 meters. So the rise is 9 meters. So we know mgh then. Do we know m?
It's given in the passage as 1,000 kilograms.
Right, so m is going to be 10 to the 3rd kilograms times 10 meters per second squared, which is g, times 9. And then we have to do 1/2 mv squared, and m again is 10 to the 3rd, and v is the final velocity. It started at 0, no kinetic energy, and ended here at 6. Remember, and I should have stated this, this is change in mechanical energy, so it's change in potential, change in kinetic. So we have 6 squared. So now we do the math. This is 9 times 10 to the 4th, plus this term, 6 squared is 36. So we have 36 divided by 2 is going to give me 18. So we have 18 times 10 to the 3rd. So we end up with, 90,000 plus 18,000. So we get 108,000. My answer choice is D, but that looks like 108.
Yeah, it's in kilojoules.
Oh,
though.
kilojoules. Kilo is 1,000. So for 46, answer is D. Question 47. In which of the following stages does the elevator cable experience the greatest tension? The easiest and quickest way to look at this is to look at figure 1. If we take a look at figure 1, it's a VT graph. And the slope on a VT graph is acceleration. And acceleration then is related to the tension or the force by ma. The greater the acceleration, the greater the force, the greater the tension. So we're looking for the greatest slope here. Now 1 would be the best answer, and it's not there. So we're faced with 6 or 3 or 4. 6 then is the best answer. 6 is a positive slope. 3 and 4 are negative slopes, and they actually reduce the tension on the cable. So answer choice is D, stage 6. Question 48. If the elevator begins its trip from the 25th floor of a 50-story building, at which floor might the elevator arrive by the end of stage 6? So again, looking at figure 1, this is the best way to do it. This figure 1 is giving you a lot of hints. Otherwise, you're going to be doing a lot of math if you're trying to figure all this out. But we've got a VT graph. And again, just think MCAT. What is the simple science? What is the simple thing they're asking me? Do I recognize a VT graph? Do I recognize acceleration is the slope? Do I recognize the area under the curve is the displacement? So if I take a look here, here's the area under this curve when it's going up. Okay, so this is all upward movement. And then this is the area under the curve when it's going down, so it's downward movement. Which looks larger to you, Jordan?
The area under the curve when it's going down.
Exactly. So it must be lower at the end of stage 6, lower than where it started. Let's see if that helps me any. It started at the 25th floor. What are my possible answer choices?
A is the 14th floor. That's the only one less than 25.
It's the only one less than 25. It's the only one possible. So I'm not going to do all the math. I'm going to look for the easy way to answer the question, the basic, simple science. Answer choice for 48, the correct answer is A. Question 49. Which of the following describes the movement of the elevator during stage 3? Take a look at stage 3. The velocity is above 0, so it's positive. That means we're moving upwards, right? And the passage describes that to let us know positive velocity is in the upward direction. So stage 3, velocity is positive, so it's moving upwards. So that gets rid of A and B. And then is it decreasing or increasing speed? Again, slope. Acceleration is negative, so the speed is decreasing. Answer choice is C.
C.
Question 50. Which of the following graphs best illustrates the tension in the elevator cable? Well, if we take a look, again, we're going to use the diagram. And remember we did the tension in the first question, in question 46, and we said greater tension, right? The greater the positive slope, the greater the tension. Over here, stage 6 is not as great a tension as stage 1. Stage 3 and stage 4 are going to have even less tension when it's sitting still or moving at constant velocity. Now, when it's moving at constant velocity, the tension is going to be?
Weight.
mg, exactly. It's going to be the weight. It's not going to be 0, it's going to be the weight because it'll be a constant velocity, so it's in equilibrium. So if we take a look, maybe that's the first way to get rid of our answer choices here. Let me slide this over. Okay, so when it's in stage 2 and stage 5, we want the tension to be equal to the weight. A is gone, and C is gone. So it's got to be B or D. Now, in stage 1, is the tension going to be greater or less than the weight?
It's going to be greater than the weight because
it's initially accelerating upwards. So stage 1 has got to be greater. Well, we still can't choose between B and D. Stage 3 is different, though. In stage 3, it's still moving upwards, but now it wants to slow down. In order to slow down, I'm going to accelerate downwards. Notice I'm moving upwards, but accelerating downwards. So if I'm accelerating downwards, I have negative acceleration. Tension is going to be less than mg, so answer choice B is the best answer here. So for 50, choice B. Jordan, you ready?
Oh, yeah.
Going down?
Okay.
Okay, we're on the standalone questions, number 51. Which of the following elements is diamagnetic? For a diamagnetic element, you have to remember that the electrons all have to be spin paired. Now, that first of all means that B and D are out because they have an odd number of electrons, so they can't be paired. So it's got to be A or C. If we take a look at A and C, magnesium and silicon, we see that silicon has 4 electrons in the P subshell. The P subshell has 3 orbitals, if you recall. When I put 4 electrons on there, looks like this, and I've got 1 that's spin paired and the other 2 are not. So that's out. So I end up with magnesium A. That's the only correct answer. 51 is A. Question 52. Which of the following molecules will exhibit the strongest intermolecular interactions? These are all nonpolar. I've got all diatomic nonpolar molecules. Intermolecular interactions are due to dipole moments. Although these are nonpolar, they do have instantaneous dipoles. And what you need to know is that when they create an instantaneous dipole, they're being polarized. The larger a molecule is, the more easily polarizable it is. Remember, the nucleus has a positive charge, and we've got these electrons flowing around on the outside. In any given moment, we've got maybe these electrons are all on one part. Notice now we have a dipole moment. This is an instantaneous dipole because it happens in a fraction of a second. Remember, for a dipole, the formula? Mu, the dipole, equals the charge times the distance. This is the distance right here. Now, for a large molecule, this distance is greater than it is for a small molecule. Right? Here you've got a little tiny d. So the large molecule gets a greater d and a greater dipole moment. The greatest dipole moment here, the biggest molecule, is choice D. 52 is D. Number 53. Which of the elements listed below will have the largest second ionization energy? For ionization energy, I think of it as energy of ionization, starts with an E, and increases to the right and up on the periodic table. That's how difficult is it to pull an electron off an atom. If we take a look, magnesium and calcium, this is second ionization energy, by the way, so we're going to pull 2 electrons off. So we pull the first electron off. Sodium loves that when you pull the first one off. It likes to be sodium plus, right? We see this all the time. It doesn't take a lot of energy. Do you ever see this? No,
Never.
Right? This is no good. Sodium hates that, so it takes a lot of energy to make that. Now, of course, potassium also hates that, so we have to choose between sodium and potassium. We know magnesium and calcium are out because magnesium and calcium love to undergo the second ionization energy. It's easy to do. Very little energy to make this. How do we choose between sodium and potassium?
Which one's higher up on the periodic table?
Exactly. We just use our rule, right? The greater energy, ionization energy is to the right and up. Sodium's higher. Answer choice is A, sodium. Question 54. For question 54, the enthalpy change at 0 degrees Celsius in 1 atmosphere for 2 combustion reactions that produce carbon dioxide are shown below. What is the standard enthalpy of formation for CO? Well, we need to know, when they ask for standard enthalpy of formation, what that means. That means we make a molecule from its elements in standard state. The molecule we're making is carbon monoxide, and its elements are carbon, solid in the standard state, plus O2, which will be a gas in its standard state. We're going to have to put that times a half in order to balance the equation. So what I'm hoping now is, with this simple science, I can add up the 2 reactions above to make this reaction. Let's see if I can do that. The first reaction looks pretty good. I've got solid carbon plus O2 gas goes to carbon dioxide gas. The second reaction, I need CO over here, so I'm going to turn the second reaction around. I'm going to put CO gas plus O2 gas is made, instead of being reactions, I'm going to put them on the product side. It's going to be made by 2 CO2. Now, the problem here is I'm making, did I do that right? Did I have 2? I have 2 CO2s. There we go, 2 COs. The problem is I'm making 2 COs here, and I only want to make 1. So what I'm going to do is multiply this whole reaction by 1/2, and that'll make just 1 CO. All right, so I get rid of that 2, I get rid of that 2, and I've got 1/2 O. There we go. So now I take a look here at what I have, and let's see if I add them together if I get the same reaction. Carbon solid, no carbon there, so that comes right down to here. O2, I used a whole O2, but I got rid of 1/2 of an O2. So I end up bringing down, I've got 1/2 left. So that worked. I make 1 CO2, but then I use it up over here. So that's gone. The CO2 is gone. My carbon monoxide comes right down there. So I have my reaction. Now the question is, what is my change in enthalpy? You notice for the first reaction, it's negative 393 kilojoules for that reaction. The second reaction I turned around. What do I have to do when I turn a reaction around?
Change the sign.
Exactly. I have to change the sign of the of the thermodynamic quality. So the thermodynamic quality, it was negative 566. That's going to make this positive 566. But there's one more thing I have to do.
Cut it in half.
Thermodynamic properties, for the most part, are extensive. So since I cut this reaction in half, I need to cut this property in half. So half of that is about 283. Positive 283 plus negative 393. I sum those together and I get negative 110. Answer choice C for number 54. Question 55. In question 55, we have, based on the reduction potential shown above, what is the potential for the reaction shown below its standard state? All right, if we take a look at these reduction potentials, give me a moment to draw this up. We have Cr3 plus an electron goes to Cr2 plus, and over here we have copper 2 plus 2 electrons goes to copper solid. Now, I'm going to do a similar thing here that I did over here. I'm going to add these up. I can't add these two directly because they're both reduction. Whenever you have a redox reaction, you have to have reduction and oxidation. So here I'm going to have to switch one around. And the final reaction I want is 2Cr2 plus. This, of course, is from the question itself. Plus copper 2 plus goes to 2Cr3 plus copper solid. Okay, I hope you can read that. So which one am I going to have to turn around here, Jordan?
It looks like we got to reverse the top one, the chromium.
Right, the chromium's got to be reversed here. And when I reverse that, I have I originally had a negative 0.41 volts. And when I reverse it, I have to reverse the voltage, right? So when I make it go this way, I go to a positive 4.1. This one's going to stay at a 0.15. Now am I done? I'm not, because look, I have to multiply this whole thing by 2. Now when I multiplied over here, I multiplied the thermodynamic property by 2. Over here, this is volts. Volts is an intensive property. Thermodynamic properties are generally extensive. Voltage is intensive. So when I multiply by 2, I don't multiply this number. So now I just add them together, and I should have plus 0.56 volts. Answer choice B. We're on passage 9, and Jordan and I thought it would be a good idea to try this reaction 1. So I've brought some water, and if we can get some carbon dioxide.
Well, we thought if we breathe out and we could capture some of that carbon dioxide, we could mix it with the water.
Well, that's a good idea. I brought a bag too. Why don't you try that for me? Jordan, didn't your mom ever tell you not to put bags over your head?
Yeah?
Okay. Why don't you take this section?
Okay. I think I'm up anyway. Passage 9. We start with question 56, which reads, in the reaction taking place in a cake batter, milk acts as, well, this is really just a reading comprehension question. It says in the middle of the third paragraph that bicarbonate ions from the baking soda combine with hydrogen ions from the milk to form aqueous carbon dioxide.
Hydrogen ions, that means protons, which means acid, so we're looking for an acid.
Milk's an acid. Let's find the answer choice that says that. Oh, my goodness, A says what, John?
Acid.
It says acid.
Now, C, the amphoteric substance?
Right, that one might trap a couple of us, but you got to know that amphoteric means can act as an acid or a base, and a base. Question 57 then. The boiling point for carbon dioxide is lower than the boiling point for water. Which of the following contributes to this difference? Essentially, it's going to be expected that you know the structure of both water with its bent structure and carbon dioxide with its linear structure. Polar, non-polar. Hydrogen bond, not.
So polarity makes stronger intermolecular forces, which raises boiling point.
Great. So let's find the answer choice that says that. Oh my goodness, B says exactly what we said. B says carbon dioxide is a linear molecule, which it is, while water is bent. Good. Let's move on. Question 58. The shape of the carbonate ion. Now this one might have been a little bit difficult for you because you might have thought, well, I didn't memorize the structure of the carbonate ion. John, do you memorize that one?
No, you shouldn't.
Yeah, that one's difficult to memorize. But what you should know is the structure, the molecular formula, anyway, of carbonic acid. Carbonic acid is a really important acid on the MCAT because combined with its conjugate base, it forms the buffer system in our bodies. And what's interesting about carbonic acid is, if we draw out the molecular structure here, we've got two hydrogens here, obviously bound to oxygens, which are bound to this carbon, which is then doubly bound to another oxygen. So we've got the H2CO3 here. If we go from this structure, carbonic acid, and we deprotonate twice, we're going to be left with an ion with two negative charges, or a two net negative charge ion called carbonate ion. So that's going to be our structure. Let's find the answer choice that corresponds to that. It's not linear exactly. It is planar, and it's got three different parts, so it's going to be trigonal planar. Best stands for 58, B. 59. When a cake batter is placed in an oven, the raised temperature. Now there's a couple things going on in this particular question. First of all, whenever you raise the temperature of anything in a chemical reaction, John, obviously what happens to the rate?
The rate always increases as temperature goes up.
Great. So the rate is going to increase, so we can eliminate two answer choices immediately, those being A and B, because they're talking about decreasing the rate when we raise the temperature. So we're down to C and D. And if you read in the bottom of the third paragraph reads, as the batter heats in the oven, aqueous carbon dioxide is released from solution as gas, causing the batter to rise. So what's going on is the solubility of the carbon dioxide diminishes as we raise the temperature. And that's probably a good factoid for everybody to know.
You should actually know that the solubility of any gas will decrease as temperature goes up.
So let's read C and D just to see. They're both increasing the rate of the reaction, but C says it increases the solubility of carbon dioxide. No, that's wrong. D must be the right answer. It decreases the solubility of carbon dioxide when we raise the temperature. Best answer for 59 is D. Question 60. Which of the following will produce the solution with the highest pH when placed in water? John, if we're looking for a solution with a high pH, what do we need to add to it, an acid or a base?
We want to add a base.
We want to add a base. So we can eliminate two answer choices here immediately. A and B have to be wrong because those are both acids. Those will lower the pH. We consider C and D. You should know, you should recognize the bicarbonate ion, especially when it's tied to sodium. This is carbonic acid. If you take one proton away from this, you get the bicarbonate ion, which is a base. You should understand, again, it's an important buffer in our bodies. So sodium bicarb is a base. As a base, it's going to function to raise the pH. That's going to be the best answer to question 60.
Now, D is also a base, right? H2PO4, but it is the conjugate base to a very strong acid. So this would make it a very weak base.
Good point. All right, and 61. A food researcher added 8.4 grams of sodium bicarbonate to a closed chamber containing 5 liters of 0.1 molar aqueous hydrochloric acid solution. If the sodium bicarb was completely converted into carbon dioxide and water, what was the volume of CO2 gas produced at STP? Now, you probably read this question the first time you said, what? I have no idea. I got to figure out a way to go because there's a lot of misinformation going on in this question. If we look at reactions 2 and 3 from the passage, however, we can see all that we really need to see if we add the 8.4 grams. We've got 8.4 grams of sodium bicarb. And what is happening and what we need to understand from these two reactions is if we start with 1 mole of this, because carbon is completely used up in the reaction, if we start with 1 mole of this, we produce 1 mole of this. And if we produce 1 mole of this in reaction 1, then in reaction 3, we use that 1 mole to produce 1 mole of carbon dioxide. So if we started with 2 moles of this, we'd wind up with 2 moles of this, and then 2 moles of this as our final product. Now that we know the molar ratios here, we know the mass, all we got to do is divide this by molecular weight. That will tell us the number of moles of this that we're starting with. That would be 84 grams.
The molecular weight of sodium bicarbonate is 84 grams.
Okay. And so what I'm going to do is algebraically we'll remove those two, and we get 8.4 over 84, which is what, John?
0.1.
We've got 0.1 moles of sodium bicarbonate. It's going to produce 0.1 moles of this, which will react in reaction 3 to produce 0.1 moles of carbon dioxide.
Now, if we have 0.1 moles of carbon dioxide, we know that a gas occupies 22.4 liters, 1 mole of a gas at STP. That's why they said STP in the question. So if 1 mole of gas occupies 22.4 liters, a tenth of mole of gas occupies a tenth of that, or 2.2. They've rounded it to 2.2. Answer choice C.
Great. And that's passage 9.
You got the hiccups? Here, try this again.
All right.
That should work.
Passage 10 is the optics passage.
All right, I'll do this one. Strange guy. Okay, passage 10. Number 62. When light strikes the lens of a projector, now here's my lens. When light strikes the lens of a projector, light is going to refract. It's going to go through and bend, and that's refraction. That's just knowledge you need to have for the MCAT. So 62 is B. Question 63. The slides must be placed upside down into the projector in order to make an upright image on the screen. Which of the following must also be true? Now they tell us in the passage the distance of the slide from the lens, P, and the projection screen from the lens, Q, are given by the relationship blah, blah, blah. And they give us the lens maker's equation. The thin lens equation. So P then is the distance of the slide from the lens. And the slide in this case is the object. Now we're using a converging lens. And what you need to know really for this question is that if the object comes within the focal distance, it's going to make a virtual upright image. If it's outside the focal distance, it's going to make a real inverted image over here. And that's what this question is really asking. So if P is outside here, we have a real inverted image. If the distance is, if P is greater than F, that gives me the real inverted image that I'm looking for. Answer choice there would be B, P is greater than F. Question 64. The lens in the slide projector must be A, and if we take a look at the lens in the slide projector, it's making an inverted image, so therefore it must be a converging lens because the diverging lens on its own will not make an inverted image. And it is also a real image because the converging lens only makes a real image. So answer choice is C, converging lens, because the image is real. Question 65. A slide placed at a distance of 6 centimeters from the lens of a certain slide projector will produce an image at a distance of 3 meters from the lens. If the slide has a height of 4 centimeters, what will be the height of the image? All right, for this question, you use the formula height of the image over height of the object equals distance of the image over distance of the object. And there's really a negative here, but typically you don't have to worry about that negative on the MCAT. It's really just telling you whether the image is upside down or right side up. It's not going to change the math here. So if we take a look, then it says the slide is placed 6 centimeters from the lens of a certain slide projector. So the slide then is going to be, this is going to be the distance of the object, which is 6 centimeters. So we're going to put everything in meters. 6 times 10 to the negative 2 meters is DO. And it produces an image 3 meters. So this will be 3 here. That's going to equal, and they told us that the height of, they want to know the height of the image. They told us the height of the slide is 4 centimeters. So height of the object is 4 times 10 to the negative 2. And then we'll solve for height of the image. Doing the math, we get height of the image is 12 times 10 to the negative 2 over 6 times 10 to the negative 2. 10 to the negative 2 cancel, and we get 2. So the height of the image would be 2 meters. Answer choice C. Question 66. The lamp on the slide projector generates a large amount of energy that must be dispelled by a fan. The fan cools the lamp by, and how do fans cool things?
Convective heat movement.
That's right, by convection, to say it simply. It is air currents moving. Convection is currents, conduction is going to be collisions when things are actually touching each other, and radiation is electromagnetic radiation. So when a fan cools something, it moves air past it, a current of air, and that's convection. Answer B.
And that concludes the optics passage. He's a Cinderella story. Zaretsky prepares for his next dive. The crowd goes silent as he contemplates his every move. All he's got to do is land this triple somersault, double Lindy with a half pike, and he's world champion, champion of the world. All he's got to do is land this next dive. Hey, hi, John. I know this kind of looks weird, but I'm actually preparing for cliff diving, man. I'm going to be the world champion. Ugh.
Okay, well.
Yeah, it needs a little work.
Passage 11, I think. Yeah.
Maybe I better start that. Give up the cliff diving as a hobby.
Keep the towel.
All right. You got it. All right. So we're looking at question 67 in passage 11. And question 67 asks, what is the approximate kinetic energy of the diver as he hits the water? Now, of course, kinetic energy we have a formula for. Now, it would be kinetic energy is equal to 1/2
mv squared.
mv squared. And the passage gives us some information. First of all, about the diver's mass. First sentence says he's 80 kilograms. And in the middle of the second paragraph, it says
25 meters per second.
Thank you.
It's really at the end of the first sentence.
Thank you. 25 meters per second. We've got to square that and cut it in half. We got half of 80 is 40.
25 squared is 625.
Is 625, which gives us, looks like about
25,000.
And of course, we're looking at kinetic energy, or a unit of energy would be a joule. Let's find the answer choice that says 25,000 joules. That would be answer choice C, 25 kilojoules, because a kilo is obviously a 10 to the third unit. 67 is C. You like the outfit, don't you? 68. How much of the potential energy has been converted to kinetic energy when the diver has reached 16 meters above the surface of the water? So in this question, we have to look. Obviously, we've got a fella diving off a cliff. And according to information in the passage, the cliff is 32 meters high. So he starts at a height of 32 meters. And we're talking about his potential energy here. Put his goggles on. We're talking about his potential energy. He starts at a height of 32 meters, and he's going to jump off. And the question asks, when he reaches a height of 16 meters above the surface of the water, what is his potential energy, or how does it compare? And of course, potential energy is based, because the formula is m GH for gravitational potential energy, whoops, the potential energy that he has is based on his height. So his height at 16 meters is half what it was as 32 meters, so his potential energy at this position is half what it was initially.
And all the potential energy is converted to kinetic energy. And that's really the trick to see at this question. If you try and do it with kinetic energy, you're dealing with V squared and figuring out V. So you should go right to potential energy here and recognize all the potential is converted to kinetic.
Thanks, John.
So answer choice B for 68.
B is best. 69. During the diver's descent through the air towards the water, which of the following quantities will remain constant? So we're looking for the one that will remain constant. Obviously, once the diver leaves the edge of the cliff, he's now a projectile. And if you are a projectile, then your horizontal velocity remains constant. In the horizontal dimension, there are no forces acting upon you. Your horizontal velocity remains constant. So Roman numeral 1 is correct. In other words, any answer choice that doesn't include 1 has to be wrong. It means D can't be the right answer. Let's look at vertical speed. Does his vertical speed stay constant, John?
No, he's jumping off a cliff.
He's definitely going to go faster and faster. He's going to be accelerated due to this acceleration due to gravity. Roman numeral 2 is not true. We've got to eliminate answer choice B as a result of that. Now we've got to consider Roman numeral 3. It says acceleration.
His acceleration is constant. It's G.
Is constant. And that might have been a trap for you. Don't fall into that trap of assuming the acceleration is not constant. The only thing affecting him is gravity. So acceleration is constant. 1 and 3, answer choice C. Question 70. The diver must time his dive with the waves coming into the shore. As the waves move from very deep to very shallow water, their velocity will. Now this is just definitionally something you have to know, that as you move from deep to shallow, the velocity will decrease. And finally, 71. By how many meters does the diver clear the rocks when he hits the water? So the question is, by how many meters does the diver clear the rocks when he hits the water? Now obviously he is a projectile, and being a projectile, he's going to be affected by gravity, but no forces in the horizontal dimension. So we can see he's in flight, according to the passage, for 2.5 seconds. So if we do a projectile problem, we know he's flying, or he's in the air, for 2.5 seconds. And that would be the first thing we have to figure out in projectile motion. Second thing we'd have to figure out is, what is his horizontal velocity? And according to the first paragraph, it says the diver's leap is directed straight along the horizontal with an initial speed of 3 meters per second. In other words, his initial horizontal velocity is 3 meters per second. And from the formula to calculate his horizontal displacement, D is equal to his initial horizontal velocity times time. Initial horizontal is 3, time is 2.5. He's going to travel a total of 7.5 meters. Horizontally. Now the trick to this, and there's an additional trick in this question, is if you answer, because you could certainly fall into the trap of answering 7.5 meters. But it also says in the passage that the diver has to clear some rocks. Specifically, immediately below where it talks about his initial horizontal speed, the passage says below the cliff is a rocky outcropping. John, you think he wants to hit the rocky outcropping?
I think it might hurt.
And this rocky outcropping projects a horizontal distance of 4 meters from the base of the cliff. In other words, there's these big bad rocks that he has to get by. So our diver is going to go 7.5 meters horizontally, which is going to put him about here, a distance of 3.5 meters from the rocky outcropping. Luckily, he's going to live.
Now, it's important to point out, I've heard people suggest you shouldn't read the passage in physics, just answer the questions. This is a perfect example where if you didn't read the passage, you're going to get the wrong answer. You're just going to look for those numbers in the passage, and you're going to pick choice D. And the answer to 71 is B, because of the rocky outcropping.
All right, I got to get back to the cliff, because my championship is on the line. So it's been fun, guys, and John, I'll see you later, okay?
Good luck.
Oh, it's cold out here.
The standalones. Finally, hang in there, we're almost done. Question 72. A sound wave is emitted into both air and water simultaneously. Observers are placed equidistant from the source in the two media. The wave will reach the observer in, and here you just need to know that sound travels faster in water than in air. So it'll reach, so A and B are wrong. Answer choice D is correct. Water first, because water is more resistant to compression than air. And the idea here is there's really two factors that cause sound to move or change the velocity of sound. The formula is velocity equals the bulk modulus over the density. So bulk modulus is how stiff the fluid is and how resistant it is to compression. So water is very stiff, very resistant to compression. So high bulk modulus, high velocity. Density will lower the speed, and water, of course, has more density than air. But in this case, the difference in the bulk modulus is more important. So answer choice D, water first, because water is more resistant to compression than air. Water has a higher bulk modulus. Question 73. An amusement park roller coaster makes a loop at constant speed, as shown below. The normal force exerted in the coaster by the track is greatest at point. So we have the roller coaster making a loop like this. We've got points A, point B at the top, point C, and then they ask, does the roller coaster, and I'll just draw the roller coaster here, maybe the roller coaster doesn't even create a normal force. That's answer choice D. There is, of course, a normal force on the roller coaster as it goes around. The normal force is just the track pushing against the roller coaster. And the question is, where is it greatest? It's going to be greatest at A because as it goes in a circle, there is centripetal acceleration. And at A, we have the track has to counter centripetal acceleration and gravity. So we have both forces countered at point A. At point B, centripetal acceleration is this way, but gravity, then, the track does not have to counter gravity. So it doesn't have to push up, of course. So answer choice there is A. Question 74. A 40 Newton force is applied to a spring, causing the spring to be compressed to a distance of 1 centimeter from its rest point. What is the potential energy stored in the spring? This is kind of a neat question because it actually requires two steps with very little information. It requires that you know F equals negative K delta X. That's Hooke's law. And here, again, the negative just means that the delta X is in the opposite direction of force. So for the MCAT, we pretty much ignore that. We're really looking for magnitudes here. So we have a 40 Newton force, and we're going to solve for K first, and we're going to multiply by 1 centimeter, 0.1. So we have 40 divided by 0.1 gives me my K. And 40 divided by 0.1 is 4000. 4,000 is my K. Then we take a look at potential energy. And the potential energy, because the question didn't ask us what K is, the question asks us what is the potential energy stored in the spring. We needed to use Hooke's law to find K. Now we can use the potential energy stored, elastic potential energy. That's 1/2
K times delta X squared.
K times delta X squared. Again, we have delta X. I'm going to write it as 10 to the negative 2 here, squared. K we'll write as 4 times 10 to the third times 1/2 will be my potential energy. So I have 10 to the negative 2 squared is 10 to the negative 4 times 10 to the third. That's 10 to the negative 1. 1/2 times that is 2. So we have 2 times 10 to the negative 1 is my potential energy. And answer choice is A, 0.2 joules. Question 75. A bar with a length of 1 meter and a mass of 8 kilograms is suspended from a string. If a block with a mass of 2 kilograms is hung from the right end of the string, how far from the left end of the bar should the string be attached to maintain the bar in rotational equilibrium? So I've drawn the diagram over here. Whenever you get this kind of thing, rotational equilibrium, what concept are we thinking of?
We're talking about torque.
Exactly. We're doing torque, and torque is going to be a statics problem. And for torque, we have to make sure that the forces up equal the forces down, the forces left equal forces right. In this case, there will be no left and right forces. And then the extra part here is torque. The torque clockwise equals torque counterclockwise. Okay. In this case, we have an 8 kilogram bar. So we don't want to forget that that means there's an 80 Newton force due to the bar's weight right at the center of the bar. And then we have the 2 kilogram weight, so that's a 20 Newton force this way. And there's another force acting on the bar. Which force is that?
Tension.
Exactly. It's being held up by tension. So what should tension equal here?
Tension has to equal the mass of the entire bar system, including the 2 kilogram mass and the 8 kilogram bar.
Exactly. So 80 newtons plus 20 newtons. Okay. Now, and so we solved for tension. That's our forces down equal forces up. Now we have to do torque. For torque, you've got to pick a point of rotation. What point you pick doesn't really matter, but well, you'll get the right answer no matter what point you pick, but calculations can be more difficult depending on what point you pick. What I suggest is you choose a point where the force is running directly through that point. If you don't, you'll have a lot more calculations. Now, which one of those points you choose, I maintain it just doesn't matter, because one way you have more calculations, and the other way it's just going to be more difficult math. So any point is really fine to choose. I think let's pick the tension point right here as our point of rotation. Okay. Now they're asking us the distance from the left end of the bar. From the left end of the bar, should the string be attached to maintain rotational equilibrium? So here's the left end of the bar. We'll call this distance x. Over here, then we have the length of the bar is 1 meter, and that's a 1 meter, okay, a bar with a length of 1 meter. Sometimes they disguise this. They'll say a meter stick is used, and realize, of course, that the bar then, or the stick, is 1 meter long. What about the 80 newtons? That acts how far over?
That's half the way. So if it's a 1 meter bar, it's 0.5.
Exactly, 0.5 meters. And then this 20 newton, how far over will that act?
That's the full length.
Yeah.
From that end.
So that's 1 meter. Now what I've drawn here are the lever arms. The lever arm is the distance from the point of rotation. Oops, I'm sorry, I didn't draw the lever arms unless I picked that as my point of rotation. You know what? I'm going to change my point of rotation because I think it'll be easier to solve here. And the reason is because I'm going to need this distance if I don't change my point of rotation. So let's just choose this end of the stick as my point of rotation instead. And that makes the lever arms the distance from where the force is from the point of rotation to where the force is acting perpendicularly. And that means in each case, that is the numbers we've drawn. So let's start with our force over here. A 1 meter force is pushing downwards this way. If I drive a nail into that piece of wood and hold that piece of wood there with a nail, and I push down on this end, which way will it rotate?
It'll rotate this way, which is clockwise.
Exactly. So this is a clockwise torque, and torque, the formula for torque is?
Force times lever arm.
Force times lever arm. So we've got the force is 20, and the lever arm is?
1.
1. Okay, go to the next force, this force. If I hold my point of rotation down here and push up here, which way does it
That's a
rotate?
counterclockwise torque.
Exactly. And the force is 100, right? Tension is 100. And the lever arm then is?
Is x.
Is x, exactly. So 100 times x. And then the last force I have is this one, the weight of the bar. If I push down, I hold my finger there and I push down, we get a clockwise force, clockwise torque, force of 80 newtons times the lever arm is 1/2. And now we use our formula. We do clockwise torques equal counterclockwise torques. So my clockwise torques, let me erase this and keep it clear. The clockwise torques then are going to be
80 times 1/2.
80 times 1/2.
And 20 times 1.
Plus 20 times 1. And that's going to equal my counterclockwise torques. I only have one, which is going to be 100 times x, or 100x. So 80 times 1/2 is 40, plus 20 equals 100x. X then is going to equal 60 over 100. X equals 0.6. This is in meters, so it's 60 centimeters. Or they actually give me the answer choices in meters. So answer choice is D, 0.6 meters. 76. A pipe with a length of 3 meters and a radius of 0.1 meters is open at both ends. What are the wavelengths of the first 3 harmonics for such a pipe? Now the fact that the pipe is open at both ends means whenever we get harmonics, we have to choose between one of 2 formulas. Open at both ends and closed at both ends would be one formula. And the other formula would be open at one end and closed at the other end. So this is an open at both ends pipe. The formula we use is the length equals n lambda over 2, where n is going to equal 1, 2, 3, ... Right? The other formula?
is n lambda over 4.
Right, n lambda over 4, where n is equal to the odd numbers, right? 1, 3, 5. We don't have the even numbered harmonics for that particular one. Okay, so here we have the length, and they tell us the length of the pipe is 3 meters. So 3 equals lambda over 2, or n lambda over 2. And then they ask us the wavelengths of the first 3 harmonics. So we're really just going to give for the first 3 harmonics, we're just going to plug in those first 3 numbers. So we plug in the first one, which would just be 1. So we have 2 times 3 meters is going to be 6 meters. Lambda for the first harmonic is 6 meters. Notice I don't have to go on and calculate everything else. It's already answer choice D. All right, 77. 2 cylindrical wires, A and B, were subjected to stretching forces. Wire A stretched a greater distance than wire B. Which of the following by itself could explain the difference? So wire A, let's say we just hung a weight. Here's one wire, and here's another wire. Let's call this wire A, and this wire B, and we just hang a weight of equal size, because equal strength stretching. All right. So what are the possibilities? What are the reasons that wire A could stretch greater than wire B? Let's look at number 1. The force on wire A was greater than the force on wire B. So if these 2 wires were exactly the same and I put a greater weight on wire A, what would you expect to happen?
Wire A is going to stretch more.
There you go. So number 1 is going to be true. So we can get rid of C, because we know Roman numeral 1 is correct. Going to Roman numeral number 2, the diameter of wire A was smaller than the diameter of wire B. If wire A is thinner than wire B, and I put the same size weight, what do I expect?
You probably expect that A would stretch more.
Yeah, it just makes sense, right? It's probably just common sense to picture that. So answer choice then is 2 is correct as well. So now we know it's got to be B or D. We look at Roman numeral 3. The original length of wire A was greater than the original length of wire B. So let's just take a look at, I'm just going to draw that so you can visualize it. You've got 2 wires, and here's wire A, and here's wire B. And now I'll just put a big weight on wire B and a big weight on wire A. Which one does it look like? These are both attached to the ceiling here. Which one does it look like would stretch longer?
A sure looks like it would stretch longer.
Yeah, exactly. And this is still kind of common sense if you stick it on there. If you stick this weight on here, A is going to stretch longer. Because let's say when you put this weight on, it stretches the bar 10%. Well, 10% of B is much shorter than 10% of A, right? Now you could have used Young's modulus for this. F over A delta L over L0 equals Young's modulus. Young's modulus is a constant for both wires. And F is the force pulling down, so that stays constant. A is the cross-sectional area of the wires. That's the same for both. They're asking what happens to delta L when L0, which is the original length, is, let's say we go from A to B. So if we decrease L0, what happens to delta L?
Has to be decreased.
Exactly. Okay. So answer choice D is our answer. Question 77 is D. And that is the physics section for test 3.
Yeehaw!
Okay, we're in bio now, passage 1. First question, 138. According to the information provided in the passage, which of the following locations is the best site for IGF-1 receptor extraction, isolation, and mapping? Here, if we look in the passage, it says that IGF is a growth factor structurally related to insulin and is produced by the liver. So pretty straightforward question, answer choice C, just reading comp.
Sure. And just a prefix, you should know the prefix hepato means liver.
Exactly. Question 139. In cases where uterine contractions are not sufficient to complete fetal delivery, physicians administer Pitocin to further stimulate muscular contractions. Pitocin is a synthetic version of which of the following compounds? Well, what they're really asking here is Pitocin does this. What hormone do you know also does this? And this is the uterine contractions. Uterine contractions
By oxytocin.
Yeah,
Sure.
choice C.
Excellent.
Question 140. Cells designed to specifically mediate homeostasis via autocrine secretion are expected to possess which of the following in excess? Well, it's said in the passage IGF-1, no, I'm sorry, we're looking at autocrine,
Yeah,
the
it's
first
right there.
paragraph. Yeah, in addition, the system relies on a vast array of low molecular weight proteins that are secreted by one cell for the purpose of altering either of its own functions, known as autocrine effects. So the key words there are protein and autocrine effect. Want to put those together. So where a protein's made, they're made on the rough ER. Choice B. Question 141. Cell cycle inhibition is followed by apoptosis, which is programmed cell death. IGF would be expected to have which of the following effects on the cellular cycle and apoptosis? So if apoptosis is cell death, IGF is a growth factor, kind of the opposite thing. We'd expect IGF to kind of inhibit apoptosis. So answer B, IGF increases cell cycle rate because it's a growth factor, and it inhibits apoptosis.
Excellent.
Choice B is best. 142. Which of the following is an example of a paracrine mediator? Paracrine mediator. These are intermediate hormones, hormones that act within the certain area, close range hormones.
Local.
Local. Thank you very much.
You got it.
Close range, within the area, local. Okay. So which of the following is an example of a paracrine mediator? And if we take a look, that would be prostaglandin. Prostaglandin is eicosanoids within the cell membrane, and they respond locally.
Great. And testes obviously not a paracrine mediator. I mean, that's a gland.
Right.
Thyroid hormone acts over the whole body, and ACTH released by the brain acts on near the kidney. So those aren't going to be local.
ACTH is endocrine. Testes and thyroid, these are endocrine glands. And we're looking for a mediator, the actual hormone, and that would be prostaglandin. So D. Question 143. Information transfer between cells is a critical feature for most biological processes. Which of the following mechanisms are involved in recognition events at the cellular surface? So we've got, this is the 1, 2, 3 question. If we take a look at the first, is number 1 involved in recognition events at the cell surface? Well, virus, target receptor interaction. We know that is, right? A virus hits a receptor on the membrane. So number 1 is right, so A and B are out. We'll take a look. C and D both have number 2, so I'm going to ignore it. I'm going to go right to number 3 because I know number 2 has to be part of the answer. So if I look at number 3, IGF-1, insulin receptor adhesion. Said in the passage, IGF-1 is a growth factor structurally related to insulin. In other words, it probably behaves similarly to insulin, which means it's going to, like insulin, it will bind to a receptor,
on
protein receptor on the surface. So 3 would be part of the answer, so answer choice is D. 144. A strong association between circulating IGF-1 concentration and the risk of breast cancer in premenopausal women was recently demonstrated. Is there any validity to this association? Okay. For this question, we've got IGF-1. We want to know this is a growth factor. Then we want to know something about cancer.
Right.
And cancer is where we have out-of-control growth. So there seems that there might be validity to this. And best answer choice here is C. Yes, mammary gland fibroblast genetic cell lines overexpress IGF-1 receptors and may rapidly divide as a result. This kind of describes the process of cancer. As opposed to D, IGF-1 is a potent mutagen which may stimulate unwanted cell division. This is not as good an answer, mainly because it's a potent mutagen.
Right, and I think that C just answers the question very directly. I mean, that's, to me, making that assumption that growth factor somehow related is a good assumption. What they clearly want you to understand here is cancer means an overgrowth of cells. And why would they overgrow? Well, one reason might be because you're making too much growth factor.
Right, and the passage says the key word here for D, answer choice D, is that IGF-1 is a mitogen, not a mutagen. Oh. It stimulates mitosis, not
mutation.
Mutation. Thank you, mutagen. Okay, yeah, but I like the way you approach that question best. C is the best answer here. It just describes cancer just right.
Yep.
Passage 2. Passage 2 is about cholesterol and steroids. Jordan, what are you doing?
Oh, I'm sorry, man. I started reading this passage and I got all nervous because my doctor told me that cholesterol is 200. So I'm just trying to figure out if he's right.
You're measuring your cholesterol with what? A stethoscope and a blood pressure cuff?
That won't work?
I don't think so.
Silly doctor.
All right, let's go. Passage 2. Question 145. Cholesterol cyclization sequence involves numerous rearrangements. When compound 4 forms a double bond to make cholesterol, the reaction is called. Now, I don't really have to look at what's going on here because the question said when compound 4 forms a double bond. SN1 and SN2 reactions, do substitution reactions form double bonds?
Nope.
Not at all.
Nope.
And how about hydrolysis?
No, that would...
No, that breaks something apart. So we're only left with E1, which is elimination, which forms a double bond. Answer choice is D. 145 is D. Question 146. Since most prokaryotes lack cholesterol, they can't make steroid hormones. Which of the following best explains how prokaryotes function without steroid hormones derived from cholesterol? All right, let's look at the answer choices. Hopanoids act as, you may know that hopanoids actually are the steroid that functions instead of cholesterol, but hopanoids act as a steroid hormone precursor in prokaryotes, and this is not true because the prokaryotes don't have steroid hormones. We're looking for a different answer. B, hormones provide an intercellular messenger system for multicellular organisms, which is unnecessary in unicellular prokaryotes. Does that make sense?
It does to me.
It makes total sense. Since a prokaryote is a single-celled organism, it doesn't need to communicate from one cell to another. And actually, that's what this question is going after. Where hormones, the endocrine system that makes the hormones, is a system made to communicate from one cell to another. And prokaryotes, of course, are single-celled, so they don't have to do that. So answer choice B is the correct answer. 147. Name one reagent involved in squalene epoxide cyclization. Well, I don't know anything about squalene epoxide cyclization except what I read in the passage. And it actually said it's followed by an acid catalyzed cyclization. So I'm looking for an acid here, sodium hydroxide.
Nope.
Nope. ALF3, this is a Lewis acid. That's my only acid there. Choice B is correct. 148. A recent IR spectra conducted on compound 3 revealed a positive functional group identification at which frequency? Now, if we take a look at compound 3, we're going to see that, well, the first thing I'm going to look for here, I see these two possibilities, 1700 and 3300. What do you think they're talking about? This is MCAT.
Carbonyl or alcohol?
Yeah, almost always this is what they're going to be talking about with the IR spectra when they ask you to memorize something. Carbonyl is 1700. Alcohol is about 3300. Now, is alcohol a narrow band or a broad band?
It's a broad band.
It's a broad band. So if we look over here at compound 3, it has an alcohol group. It does not have a carbonyl group. So we're looking for about 3300. And then we're looking for broad. And answer choice D, broadband. 149. Serum lipoprotein levels are a good indication of a person's risk of heart disease. According to Table 1, these compounds are categorized according to the density of which component? If we take a look at Table 1 and we look under percent protein, we see that it's increasing as we go down. And we see that as we go down that chart, and we look under density, the density gets greater. So we go from very low density, VLDL, very low density lipoprotein, to HDL, high density lipoprotein. So this must be categorized by protein concentration. Choice C.
I think that's a tricky one because I think the assumption on that particular question is if you see LDLs, and obviously we associate it so much with fats, I think the trap answer there is lipid percentage, answer choice A.
Good
so
point.
If you got caught on that one, understand it. What you didn't do was you didn't read the table.
Question 150. According to the reaction mechanism, which of the following structures represents the reactive intermediate that may occur as compound 3 is converted to compound 5? Now, if I'm looking at this compound 3 is converted to compound 5, the intermediate is compound 4. So I'm going to take a look at compound 4, and I'm going to look at the answers then and see which answer choice most resembles compound 4. And if we take a look, compound here, answer choice C is the closest. In fact, I think it is compound 4. So answer is C. Hey, how you doing? Nice to see you again.
Mm-hmm. So we're working in the third passage from the biological sciences section.
Okay.
Okay, let's take a look at this third passage. Oh, we'll look at that book.
Passage 3.
Question 1.
51.
Drug Y binds to its receptor with an
intrinsic activity of value of
0.0. Which of the following best describes
the role of
drug Y?
Okay. If it has an intrinsic value of 0.0, if we turn the book over here and take a look, in the passage it says, drugs with intrinsic activity of less than 1 but greater than 0 are called partial agonists.
Oh.
So we know it's not a partial agonist.
Because it has a value, according to the question, it has an intrinsic value of 0.0.
Right.
Can't be a partial, and
It's
also
not a full agonist because that would have an intrinsic value of 1.
Excellent.
So it's either a defective enzyme or a competitive inhibitor. And in this case, it's a competitive inhibitor because it binds to the protein, but it doesn't cause any of the protein, it doesn't cause the protein to respond. So the best answer here is choice D. Question 151 is?
D. 152.
According to figure 2, 1
mole of signaling molecules
binding to 1 mole of surface receptors
may trigger the production of as many as approximately
how many moles of enzymatic product? Okay. All right, let's take a look at the diagram here.
Figure 2.
Yeah, figure 2, we see that one signal molecule causes at least 5 GTPs, which in turn causes 5 cyclic AMPs. That's going to be 25 already. 5 more protein kinases, which is going to make it 125. 5 more enzymes, 625, and so on. And this is the cascading principle discussed in the passage. Okay. So our best answer choice here then would be D, 3,000. Just a really big number is what we're looking for there.
Absolutely.
Okay.
Okay.
All right. The drug receptor binding involves
transduction of drug receptor binding.
I'm sorry, you're correct. Transduction of drug receptor binding
involves enzyme activity that has a duration much longer than the drug receptor interaction. Which of the following
statements best explains these observations? Okay.
At first glance, this is a very difficult question, and you have to ask yourself a couple things. First, there's a whole lot of words in each, first of all, in the question and in each of the answer choices, so it gets confusing that way. Let's look at each one sort of individually. A says, not all drug receptors need to be occupied, and the intracellular signal amplification produces the maximal drug effect.
Well, A is a true statement, and it actually answers the question.
It sure does.
Because you're not going to have a drug occupy every protein on the membrane. So in this case,
A is better than, for example, D. If you got trapped perhaps by D, it says at least half of all drug receptors need to be occupied, and the intracellular signal amplification produces the maximal drug effect.
And that's just not true.
Right.
There's no reason to think that.
That at least half. So if you chose D, you made an assumption that was bad.
Okay.
Choose A next time.
Let's go on.
154.
Calmodulin is a protein containing 148 amino acid residues. Calmodulin
undergoes conformational changes in the presence of calcium ion, allowing it to bind to other cytoplasmic
proteins and affect cellular responses. Calmodulin is most
likely which species from figure 2?
Yep. Well, if we take a look at figure 2 here, we want to, calmodulin is a second messenger. And a second messenger here is cyclic AMP, and you should just know this.
Absolutely. Basic science knowledge, the best answer to this question will be C, cyclic AMP, because they're both second messengers.
Correct.
Excellent.
Question 155.
Hormones of the hypothalamic pituitary endocrine axis rely on a cyclic AMP second messenger mechanism. Which of the following hormones does not rely on cyclic AMP?
Oh, pardon me.
That's all right. We're working on question 155.
155. Which of the following does not? Oh, because cyclic AMP, this would depend upon a second messenger system. So we're looking for a steroid hormone that doesn't act through second messenger. And the steroid hormone there is aldosterone. There. So
aldosterone has the word steroid built right into it. answer choice C is best for 155.
Very good.
Excellent. Shall we move on to the next one?
Yes, question
156.
The transmembrane protein receptor,
G protein, is most likely an evolutionary upgrade from which of the following?
figure 1 receptors.
Okay.
All right, if you take a look at your figure 1, you're going to notice that, first of all, let's take a look at figure 1, that choice B looks very much like the G protein receptor, so that's the wrong answer. No, I'm sorry. Choice D looks very much like the G protein receptor, so that's the wrong answer.
This is the G protein receptor here.
Exactly.
So that's not the right answer. We're looking for, as the question asks,
the evolutionary, the one that was upgraded to the G protein.
And that one to me looks like answer choice B.
Correct.
Similar to the G protein.
I would agree. It's got it's missing one aspect of the G protein. So it's prepared to be upgraded evolutionarily. So answer choice B is the
right answer for 156. You know, I'm quite thirsty. Shall we move on then?
Let's move on.
Okay.
157.
Cell division is controlled by a cascading mechanism as described in the passage. Growth factors
Bind to a receptor protein that phosphorylates an intracellular
protein called RAS, which in turn activates a phosphorylation
cascade leading to cell division. The highest
concentration of growth factor for actively dividing cells of growing tissue
will be found
where? So what's going on is we've got growth factors binding to a receptor protein. Where's that going?
Aha, proteins. So the key word is proteins there, and our best answer is choice A, at the rough endoplasmic reticulum.
I do believe you're
incorrect.
Close.
Yes. Why is that not the correct answer? Because they're asking about where the binding occurs, and the binding occurs at
the cell membrane. Best answer for 157 then is B.
Right. I apologize. I was actually thinking with his brain for a moment. Okay. Very good.
So I think it's lunchtime. Shall we go out and get some good lunch?
Too. Let's go to lunch. Thank you.
See ya. Hey, look, John. I got a Q arm and a P arm.
You're a funny guy. Okay, let's do passage 4. All right, and he's talking about the arms on the chromosome. The long arm, the Q arm, and the short arm is the P arm. Let's go to question 158. For 158, it says 46XXT whatever that code means, reciprocal translocation occurred between the short arms of chromosomes 3 and 6. What are the possible phenotypes of the carrier's offspring? Again, they're giving us a lot of extra information here, so I want to focus on what I do know, the kind of simple stuff. Reciprocal translocation, that's what the passage was about. This is one of the reasons you should read the passage before you attempt the questions, because you can shorten the questions this way. You can really focus in on what they're asking about. It says in the passage that the reciprocal translocations can come out with a phenotypically normal. So we know number 1 is there, so C is out. And then we have to look, is number 2 in there, carrier of a balanced translocation. It also says in the passage that's a possibility. And then number 3, balanced genome that contains 45 chromosomes. The 46 means 46 chromosomes, not the 45. So answer choice must be B, 1 and 2 only.
If you missed the phenotypically normal part in Roman numeral 1, if you look in the middle of the 3rd paragraph, it says a carrier of a balanced reciprocal translocation has increased chance of having abnormal progeny. In other words, they can also have normal progeny. And I just wanted to make the point that it's really about vocabulary. Phenotypically normal means that you're normal. You don't have an abnormality. And in the middle of that paragraph, they hide the definition or the response to Roman numeral 1.
All right. Question 159. There are numerous single gene disorders occurring in only one of 2 homologous chromosomes that leave an individual susceptible to cancer as part of their phenotype. The majority of these most likely exhibit which pattern of inheritance? Jordan, you want to take this one?
Sure, John. It says in the question that there are numerous single gene disorders. And the thing about single gene disorders, if it only happens on one gene but not both alleles, if the disorder is felt phenotypically, in other words, if you get cancer from it, it must be because that disorder is a dominant disorder. It can't be recessive. So we can cross out a couple of these answer choices immediately, A and D. Now we're down to B and C, and it helps to simplify the problem. If it's mitochondrial, that means it's fairly local. It's not going to affect the whole cell in your whole body, versus autosomal dominant, a lot more sense that an autosomal dominant single gene disorder will affect you and your whole body, not just a mitochondrion.
And there'll be no homologous chromosomes in a mitochondrial DNA.
That's true.
Right. So basically you're saying we have two alleles in an autosomal dominant. If we just have one of them affected, we get the phenotypic disorder. If we have, and it says here, this is a single gene disorder. That's what a single gene disorder is. Got it. Okay, question 160. Chromosomes 21 and 22 readily undergo Robertsonian translocation. Based on this information, which of the following can be said of chromosomes 21 and 22? So here, we're going to look at figure 1, which is the Robertsonian translocation. And then it's going to be reading comp, because we notice the questions want to know, is it acrocentric or metacentric? And the passage says that the acrocentric is, Jordan, you see what
in
it
the
says?
first paragraph, it says, while acrocentric chromosomes have a peripheral, in other words, near the chromosome tip centromere, metacentric chromosomes have a near central centromere.
I see. So a metacentric, right, would be something closer to the center of the entire chromosome. And these would be acrocentric. And these are undergoing the translocation. So we know it's acrocentric, so that narrows it down to A and B. And then they're acrocentric with a long P arm and a short Q arm. And we can see here that really the Q arm is long and the P arm is short.
Exactly. Must be B.
Must be B. 161. Down syndrome is most often caused by a failure of the sister chromatids at chromosome 21 to separate during anaphase 1 of meiosis. This failure of separation is called, so if we take a look, they're talking about anaphase 1 of meiosis. In anaphase 1 of meiosis, we have the tetrads. Really, this would be metaphase, right before anaphase. In anaphase, these two tetrads are going to separate. These are sister homologs, chromatids, so they're homologous chromosomes. And they're going to separate like this in anaphase 1. That separation is called disjunction. So if they don't separate, it's called non-disjunction. So it's either A or B. It's primary non-disjunction because this is anaphase 1. If they didn't separate, after these separate, then you'll get this, and then in anaphase 2, these two will separate, and you'll recall you'll get something that looks like this. This would be secondary non-disjunction. So we're looking at primary non-disjunction because they said anaphase 1. Question 162. A woman is a carrier of a balanced translocation and is at high risk for abdominal infection, which result in scar tissue formation that forms a barrier between the ovary and the uterus. Which of the following is the most likely effect of such scarring? If we have a barrier between the ovary and the ovary can't deliver the eggs, can't release the eggs so it can get to the uterus. So increased menstrual flow? Not necessarily, right? Or not necessarily decreased either. Infertility? Yes, the egg can't get to the uterus, we don't get pregnancy. Decreased ovulation? Again, this sounds like maybe it's a good answer, but we know for sure B is a sure thing. If the egg can't get to the uterus, we don't get pregnancy. We don't know for sure that ovulation would be stopped, because what causes ovulation?
Well, it's hormonal, so...
Yeah, LH and FSH, so we don't know if scarring will have anything to do with that. And then D, decreased levels of estrogen. Again, we don't know if that's going to happen. We know for sure that we can't have pregnancy. Question 163. Which of the following is not the result of mitotic cell division? Mitotic cell division, if we look down the answer choices, this is a pretty straightforward question, does not form gametes. Gametes are formed by meiosis. So answer C is correct. Question 164. The heterozygous carrier of a Robertsonian translocation involving chromosomes 14 and 21 is phenotypically normal, since there are two copies of all major chromosome arms. However, there is a high risk of trisomy 21 among the offspring of such a carrier. Offspring suffering from this special type of Down syndrome will have 46 chromosomes. Below is the genotype of a carrier and parent and a normal parent. Which of the following is the trisomy 21 zygote of the offspring? All right, so this question looks like it could be complicated. If we take a look at the normal parent and the carrier parent, we're going to get a cross. And the normal parent's going to give, it can make 4 different gametes. These two, these two, these two, and these two. So we might take a look at the answer choices, and we see that all of those, each one has that. So that doesn't get rid of any of the answer choices for us. But it says in the question they have 46 chromosomes. This one is out because it has only 45 chromosomes. This is a normal, there's no trisomy 21, so this one's out. So we're C and D. And how do we choose from C and D? Jordan?
It says in the last paragraph that Robertsonian translocation is the centromeric fusion, blah, blah, blah. It says the P arms form a fragment that is generally lost within a few cell divisions. Each affected cell has a total of 45 chromosomes, and the karyotype of the Robertsonian translocation carrier shown in Figure 1 is designated as 45XYT 14Q21Q.
So it's really, to simplify it, it's really Figure 1. We look at Figure 1. This is a Robertsonian translocation here, and look what we have. We have this chromosome. So we need that one over here, which is right there. So this is the pair given by the gamete from the normal parent. This is from
Carrier
the carrier parent. And so that's answer choice C.
All right, we're going to look at the first set of freestanding questions in the bio section, starting with question 1. What are you doing over there, man?
I'm just getting a little slap happy, but I can take it. I'm a warrior.
Oh, brother. 165. Which of the following bond types is most responsible for maintaining the integrity of the phospholipid bilayer in a eukaryotic cell? In a eukaryotic cell, I've taken the liberty here of drawing the phospholipid bilayer. John, would you agree? Can you even see it? The phospholipid bilayer here, we got our phosphate groups and our lipid parts in the middle there. And it says, which of the following is most responsible for holding that thing together? We know if we're talking about the interior here, it's not hydrogen bonding because these are lipids, these are fats. They don't hydrogen bond. A is out. B is covalent bonding. That would be intramolecular bonding. That's not what's going to happen between molecules here. B is out. C says hydrophobic interactions. Aha, that's the one. That's the ticket. You need to know that hydrophobic interactions, things that fear water, is what's going on in the middle there. C is the best answer for 165. Can you see that one?
I can see it, just barely.
All right. 166. When carbohydrates are consumed, they consist of several different sugar molecules, sucrose, maltose, lactose, etc. Where in the GI tract does disaccharide digestion take place? So a little bit of misdirection in the beginning of this question, and then the science that you actually have to know. And the science you have to know is disaccharide digestion occurs right on the brush border enzymes, or on the brush border of the jejunum and ileum, and it occurs by activation of the enzymes along that border. So at the brush border enzymes of the jejunum and ileum, answer choice C.
Now, some of you may have tried to answer choice D here via salivary amylase in the mouth, which does break down carbohydrates, but not the disaccharides, and that's the key difference here. Do you agree with me?
I do. Thanks, John.
Doctor.
Or should I call you Lars?
Call me.
167. All DNA viruses except the
Parvoviridae
are double-stranded. Compared to the typical DNA, that's you.
The typical DNA.
The typical DNA, what's that word?
Viral DNA. I can't read it, actually. Oh, Parvoviridae.
Yeah. DNA will have fewer of what type of bonds? You need to understand that double-stranded DNA is held together by what kind of bonds?
Well, hydrogen bonds, of
Hydrogen
course.
bonds. Let's find the answer that says, oh my God, B says it directly. B is the best answer for 167. Thanks.
No, it's more difficult to take the test in these glasses.
168. Glucose is a pyranose. The cyclic compound above is gulose. Which ring type in diastereomer description correctly classifies this compound? Well, let's see. We've got gulose, and if you look at it, we've got 6 members in the central ring, just like glucose. So if glucose is a pyranose, this thing has to be a pyranose as well. That's going to eliminate a couple of answer choices. C and D are out. Now the question is this a beta or an alpha anomer pyranose? Well, remember, and I think we've seen this before, it all depends on the anomeric carbon and where its substituency that involves oxygen is hanging. If that substituency is pointing upwards, it's a beta anomer, and if it's pointing downwards, it's the alpha anomer. This one's pointing upwards, it must be the beta anomer. Answer choice A.
So when looking for the beta or the alpha, you need to ask yourself, how's it hanging?
Oh my God.
Hi, we're here doing passage 5. Okay, we're going to start with question 169. Morphine is poorly absorbed by the GI tract and thus is administered parenterally via an IV solution. So far, I really don't care too much about that because I'm taking the MCAT and there ain't nothing I need to know about
I
that.
tell you, they're talking about my GI tract, if you know what I'm saying.
After examining figure 1, what is the appropriate three-dimensional description of this analgesic? Now there's the meat of the question.
Oh, man, the potatoes, too.
I have taken the liberty of drawing out morphine, as you see here. Okay, a very dangerous drug. If we look at the answer choices, is it pentacyclic, cyclic meaning circle, or is it tetracyclic? 1, 2, 3, 4, and then they got this big circle right here, 5.
5 of them.
5 circles, so it's A or B, it's penta. And then is it an alcohol or an alkyl?
Oh, okay.
Alcohol.
Because it got the hydroxyl there.
You betcha.
Okay. Well, we
All
got
right.
an A on that one.
Answer
That's
choice
answer
A.
A. 169.
Okay. 170. Malic acid, a secondary alcohol, has been isolated from pairs. Well, who cares? You know what I'm saying? Again, it's misdirection.
Well, point
They're
that way,
trying to trick me. They're trying to confuse me. You can't confuse this steel trap.
It's like a bear trap, yes it is.
You better believe it. Identify malic acid. What's the point of this question? We're looking for a secondary alcohol. I got the diagram right here. It'll take me a second to bring it up. Okay, here it is. Okay,
Oh, there you go. Got it.
where is my secondary alcohol?
Okay.
A secondary alcohol, this one is not a secondary, it's a primary.
Only bound to 1 carbon, that one.
That's
there.
right. B looks to me like a secondary.
Holy
I like
moly.
that one. This one ain't even an alcohol.
No, got the carboxylate groups on the outside there, but
And this one, this is a tertiary alcohol.
but that's not what we're looking for. That's
Looking for a secondary.
secondary.
B.
B.
B is the right answer. Do you notice here, the whole thing about pairs and such ain't even important.
It does point out the fact of why I like to eat my pears so much, though. You know what I'm saying?
I ain't got a lick of an idea what you're saying.
Well,
Okay, moving on to question 171. Which of the following species are an electrophile and nucleophile, respectively? Okay, so an electrophile, we're looking for something that likes electric negative charge. So we want a positive charge. So let's just get rid of B and C right off the bat.
Get rid of them.
They're gone.
All right.
Okay, and the nucleophile is something that's going to like negative charge. So we'll get rid of A.
Oh, my goodness.
So I guess
Well, you done took
No,
care of everything
nucleophile-
except D. It got to be D.
nucleophile likes positive charge, so we get rid of A. Sorry. Yeah, so A's gone. So we're left with D.
D's got to be D.
BCl, right, a Lewis acid, and ammonia, which we know is a
base.
good nucleophile.
Yeah,
Base and a
okay.
good nucleophile.
This 171 is D after all. He's a smart guy, isn't he?
All right.
Okay.
Okay. Now we go to 172. Oxymorphone is prescribed for pain relief. Okay. Prescribed means the doctor's going to give it to you. I'll make a little change here. We'll make oxymorphone.
Okay, I'm going to just jump to the answer choices
Go
here.
ahead. Go ahead.
Based on the information in the passage.
Speedy Gonzales.
Well,
Don't
you
wait
can
for me.
eat my dust.
Okay. Based on the information in the passage, oxymorphone most likely.
Well,
Go ahead.
If it doesn't have analgesic properties, my doctor better not prescribe it for me for
pain
no pain
relief.
relief. I'm eliminate A. Otherwise, I'll be firing another. Oh, there, okay.
Yeah. A's out. B is a natural product it said in the passage there are only 2 natural products of the poppy seed. That's morphine and codeine. So oxymorphone ain't no natural product of poppy seeds. And C is an artificial derivative of morphine. Looks like it could be. I made a couple simple changes.
That's pretty close, yeah.
Cannot be demethylated by the liver. I don't see why not. If morphine is, why couldn't oxymorphine be?
I did knock that methyl group right off there.
So C is your right answer.
Gotta be.
Last question in this passage.
Yep.
You ready?
Oh.
173. Based on alkaloid structure and information presented in the passage, which compound would probably have the weakest analgesic effect?
Weakest.
Okay, we got a board here.
Oh!
I think I need your help.
Oh, dear Lord. Here I come. Okay. No, don't get excited now. I'm just waiting for me.
Okay.
There we go. You okay?
I'm okay. Thanks. Let's get that board. Heist. Come on, you do this problem. You're up here. You're up here.
Here we go. Here we go.
Okay. All right here. They said in the passage that the liver demethylates morphine and some other alkaloids. And so if it demethylates, that's the methyl group on the N, right? Right?
Looks good to me so far.
So we think we could demethylate this one, and this one, but D, we can't, it ain't got no
There's
methyl
no
group.
methyl group there. I mean, that can't be the right answer then.
Which compound would probably have the weakest analgesic effect? It's been demethylated.
Oh, yeah, that's right. Are you okay there? You okay? Okay, I'm gonna warm up for this one. Oh my goodness. Oh.
173 is D.
John, I can't believe you're staying out late again tonight. Can you believe that,
I
Jordan?
can't believe him.
And Jordan, you're with Jordan? I just can't believe it.
Those boys.
And what time will you be home? Fine. Don't expect me to be here when you get back.
You know what, Joan? I have an idea. Why don't we do another passage just to spite them?
What a wonderful idea. Wonderful. Passage 6.
Okay.
Ooh, it's about testosterone. Oh, the boys are full of testosterone. Too much, if you ask me. Testosterone has a negative feedback effect on the anterior pituitary, inhibiting the production of FSH and LH, and on the hypothalamus, inhibiting the production of GnRH. An athlete injecting testosterone to enhance his performance might expect all the following except. Okay, he injects testosterone to enhance his performance. I imagine his athletic performance.
Yes.
And what would that do? That should increase his muscle mass, right? Testosterone increases muscle mass.
Absolutely.
That should decrease spermatogenesis because, it's okay, this is science. It should decrease spermatogenesis because the testosterone acts on the Leydig cells, right? No, it should, because it said in the passage that inhibition of production of FSH and LH, and thus preventing the production of sperm in his testicles.
So that wouldn't be correct. B is out.
B is out, yes. And C, increased testosterone production of cells of Leydig. Well, if he's injecting testosterone, the body's not going to say, hey, I need some more testosterone.
True
right?
enough,
It's
dearest.
got enough already.
Right,
so
so
the
he
body's
wouldn't
going to
have
say,
increase.
turn those babies off. Just shut them down.
Wow.
Exactly.
C must
is
be
a
our right
good
answer, yes.
Yeah. Let's just look at D.
Okay.
Decreased FSH and LH production by the anterior pituitary. It says that right in the question.
Yes, it does. C must be the right answer.
C
173.
is the right answer.
You're so wonderful at this, Joan.
Oh, thank you, Jordine. Okay, 175. Based on information in the passage, which of the following regulates male sex hormone production? All I can say is, who cares? Okay, but really, let's answer the question.
Okay.
All right, so based on the passage, it says that LH stimulates the cells of Leydig, and the cells of Leydig then create the testosterone, so it must be LH. Mm-hmm. What do you think?
I think you're absolutely right.
Choice A. We'll go with choice A.
Joan, you're gifted, absolutely gifted at this.
Oh, stop. Okay, you're right, though. 176. A researcher experiments cloning elephant cells. If the in vitro environment surrounding these cells varies too much from normal conditions, these cells will experience...
Oh, my.
Well, in vitro, what's in vitro?
Oh, in vitro. Well, that would be in somewhere, wouldn't it?
Yeah, I think in vitro would mean in the lab, silly.
Oh.
In the lab, okay.
In the lab.
So the in vitro environment surrounding the cells varies from normal conditions.
Well, normal would be normal.
Normal would be good, I think. And in the lab, it's stuffy, cold.
Oh!
What's the best answer? I think death. The cells may experience death.
And the key to this one would be in the question itself, where it says varies too much from normal. Of course, anyone would die if it was too much from normal.
Oh, Jordan, you're so good at the details.
Thank you, Joan. I'm learning from you, clearly.
Okay, so 176 then is B. 177. The Leydig cells are typical steroid-producing cells that possess mitochondria with tubular cristae. What else is most likely true regarding these testosterone-producing cells?
So these cells are steroid producers. They're good at making fats.
You're correct. The lipids. And where do we make lipids, Jordan?
Smooth endoplasmic reticulum?
That's correct. So these cells must have an overdeveloped smooth ER, tightly associated with a well-developed Golgi to deliver the steroids.
I love tightly developed Golgi.
Oh, yes, you're so right.
Answer choice B must be correct for 177.
I agree. Mm-hmm. Okay, I think that's all. I think we're done.
Okay.
Wonderful job. I'm going to call and see where those boys are right now. Passage 7. Jordan, you're doing passage 7, right?
Yeah, you know what? I just realized, can we take a 5-minute break?
5 minutes? Forget it.
Just 5 minutes.
No, this is a
John,
long
promise.
task. We're right in the middle. Let's get it done.
Just 5 minutes, please.
No.
So let's look at passage 7. Question 178 is first. Question 178 reads, where would most of the biotransformation reactions shown in figure 1 be expected to take place? Now, of course, if we look at figure 1, we can see that all these reactions are the detoxification of acetaminophen. Of course, detoxification is going to occur in the liver, so the answer to question 178 is C, the liver. Question 179. All the following statements correctly describe the outcome of biotransformation reactions except...
Right, and this one's easy to answer because by figure 1, at the bottom right-hand corner there, you've got the toxic metabolite. Figure 1 is all the biotransformations. So 179 must be D. All biotransformed products are non-toxic. It's an except question, so D must be the answer.
John, would you mind closing that door? There's a draft in here.
Gladly.
Moving on to question 180 then. Question 180 reads, when acetaminophen dissolves in the blood, which of the following structures does not contribute to its solubility in the aqueous solution? Of course, what this question is really asking is, which of the 4 intermolecular hydrogen bonds is not a valid structure? And if we look at answer choice C here, we can see that the hydrogen bond formed right here is not valid. Why? In order to form a hydrogen bond, this hydrogen must be bound intramolecularly to either fluorine, oxygen, or nitrogen. It is not, it's bound to carbon, and of course, that can't form an intermolecular hydrogen bond. Choice C is not a valid bond. Moving on to question 181 then. To answer question 181, we need to refer back to figure 1. Question 181 then reads, when acetaminophen is introduced into the body, what percentage of it will undergo phase 1 reaction? Now, it says in the second column right at the top
that biotransformation phase 1 reactions consists of oxidation, reduction, and hydrolysis. It then goes on to state, phase 1 reactions change the parent compound by 1 to 3 atoms and prevent its passive diffusion into cells. Well, if we consider figure 1 then, what we can see is that if we go to acetaminophen glucuronide transformation, of course we've added an entirely new structure to the initial acetaminophen. That's more than 1 to 3 atoms. And conversely, if we consider what's going on in acetaminophen sulfate synthesis, we are again adding more than 1 to 3 atoms. So it's only when we go right down the middle here where we see mixed function oxidases where we're not changing the original acetaminophen compound by more than 1 to 3, this 5% must be the 5%, must be the answer to the question. So once again, the answer to 181 is C, 5%. 182 then. Which of the following organs is expected to have the highest concentration of endoplasmic reticulum, mitochondria, and cytosolic biotransforming enzymes involved in detoxification? Now, of course, what's going on here is this is a very similar question to a question we saw earlier where we saw that the liver is the organ or body system involved in detoxification. This question gets a little bit more specific. It is the smooth endoplasmic reticulum within the liver that actually does the biotransforming or the detoxification. Best answer for 182 is B, the liver. So finally, we move to question 183, which reads, which of the following is a possible reaction catalyzed by a cytochrome P450 enzyme? Now, the trick to this particular question is that in the second column of the passage again, it says P450 dependent oxidation is the most important phase 1 reaction. So when we look at the answer choices, what we're looking for is an oxidation reaction. So let's consider A, B, C, D, and consider which of these might be an oxidation reaction. Now, keep in mind that oxidation means forming more bonds to oxygen, and reduction then would be the opposite, breaking bonds to oxygen or forming bonds to hydrogen. We'll start with answer choice D, where we can clearly see we start with an aldehyde at the top of the molecule, and at the end of the reactions, we have new bonds built to hydrogen. D must be a reduction reaction. It can't be oxidation. It can't be correct. Answer choice C, we've got no bond to nitrogen in this part of the molecule, and then at the end of the reaction, we've got a new bond built to hydrogen. Again, this would indicate a reduction reaction because of the new bond to hydrogen. C can't be correct. Now, in answer choice B, what's going on is that we're building new bonds to hydrogen at the base of the molecule right here. Here we don't have any hydrogens. Here we do have hydrogens. We've created new bonds to hydrogen. We must again have a reduction reaction, and answer choice B can't be correct. And finally, answer choice A then, we're still looking for our oxidation reaction. We start with a primary alcohol at the top of the molecule in answer choice A, and by the end of the reaction we have an aldehyde. So we built new bonds to oxygen and broken some bonds to hydrogen, which must mean that we've got an oxidation reaction built into answer choice A. A must be the right answer. Okay. Oops. Oh. So working on past, oh my God, what is that light? Oh my God, John, it's your head. Somebody pancake his head, please.
That's it. I'm tired of these ball jokes. I'm just tired of it. Got a new look. I'm going with hair now.
I got to tell you, I'm happy because at least I won't have to deal with the glare.
All right, let me do this one.
You got it.
Okay. Question 184. An elderly patient with chronic heart failure has been admitted to the hospital. Which of the following conditions will reduce his peripheral edema? All right, edema. What's edema?
It's swelling.
Right. On the MCAT, that's all we want to know about edema. We're just talking about swelling. And when we have swelling, it's swelling due to too much fluid. How do we get rid of that fluid, or what organ in the body or what organ system is designed to remove the fluid in the body?
Our lymph system.
The lymph system. So choice D. It's hard to have so much hair. Question 185. The etiology of hypertension is multifactorial. Which of the following factors is most directly involved in increasing blood pressure? So the key here is just they're asking increased blood pressure, which one of these factors goes with it? So here if we take a look, the best answer is B, cardiac output. Now, the way to get this answer is not start thinking about angiotensin II, plasma volume, and these other things, but actually go right to the chart in figure 1. And we see blood pressure is most closely related by the chart with cardiac output. You might come to a different conclusion if you used your science knowledge, but what you want to use on the MCAT is first the information that they give you. So cardiac output directly related to blood pressure. This air is killing me. All right, 186. Blood pressure is regulated by this organ and is highest at this site, respectively. Now, on these kind of questions, you can generally answer it by looking at one side or the other. There's a two-part answer here. You can use the first part of the answer or the second part of the answer. In this case, it's easier, for me anyway, to use the second part of the answer. Blood pressure is highest at the inferior vena cava? No, not in the veins. At the aorta? Yeah, that's where I'd expect a lot of blood pressure. The heart is pumping the left ventricle, where we get the most pressure, is pushing blood into the aorta, high pressure. Capillaries? No, we don't expect high pressure in the capillaries. They'd burst if the pressure was too high. And then lymphatics? Not at all. Okay, so answer choice there would be choice B. Question 187. When a person moves from supine to standing position, blood pressure rises. Which of the following compensatory, that's a key word here, compensatory changes occur to create this increase? So if we're looking to see what happens when you stand up. It tells us when you stand up, blood pressure rises. So what does your body do to create that increase? Vasodilation?
No, that would be the opening of vessels and arteries. So.
Right, it actually creates more volume, and we know when volume goes up, pressure goes down. There's more room for that many moles of blood. Increased GI contractions.
Well, that might happen too, but...
That, we'll leave that one blank for a minute, but it doesn't seem like a great answer, maybe not a bad answer. Increase in peripheral resistance.
Aha.
Yeah, if we increase resistance, pressure will go up. In fact, we have that equation, which is pressure equals flow times resistance. So resistance goes up, pressure goes up. We want to be careful when we use that equation, but in this case, we can use it at least as an analogy. And then, so C looks like a good answer. And then D, increase in striated muscle tone. This doesn't look as good as answer choice C. And really because of this formula, because you should just understand, if we increase the resistance, we're going to increase the pressure. 188. A patient is admitted to the emergency ward with a blood pressure reading of 85/50. The denominator of this value is known as the diastolic reading. What does the diastolic reading of 50 represent? Do you want to take this one?
Sure. This is by definition, this would be the pressure within the left ventricle while the ventricle fills, including the final contraction or the contraction of the atrium above it, pushing that last amount of blood in. That would be the maximum pressure that we'd see.
So 188 then would be?
A.
A, pressure within the left ventricle during filling.
Right. And systole would actually be B, the pressure within the left ventricle during emptying. Contraction of the heart pushes blood up into the aorta. That would be the systolic number, or the systolic figure in the upper figure in the blood pressure.
Okay. I've got to go see my hairdresser.
You do, man.
I'll see you later.
We're up to the second set of freestanding questions in biology, starting with question 189. Which of the following is the strongest acid? So we're looking for the strongest acid. I'm going to immediately look at answer choice D and eliminate it. Why? It's not an acid. It's definitely a base. It can't be the strongest acid. It's group. The others, you should know that ethyl alcohol, any alcohol, is going to be a weaker acid in general than water. Not in general, weaker acid than water. And propane, of course, is an alkane. They're not acidic. So it's kind of a funny question, but the strongest acid of this set is water.
Yeah, there is no acid here, it seems, unless you think about the definition of an acid. And the definition of an acid simply, let's take the Bronsted-Lowry definition, just a proton donor. Water can donate a proton. In fact, any of these can. So, yeah, the strongest is water. Very good.
190.
Sex pili are used to transfer genes from one bacterium to another in, and you should know this one, conjugation. The F plasmid goes from one bacterium to another by track or by way of a sex pilus in conjugation. Binary fission, of course, is not genetic recombination. That's just splitting bacterium. And transduction involves using a virus as a vector. And collaboration, that's just bacteria getting together and working out together.
I guess. I don't know.
191. Which paired structure does not represent resonance forms with electron delocalization? So we happen to have the structure of this particular question, or the answer choices to this particular question. And what jumps out to me immediately is this answer choice right here. I've never seen a resonance structure drawn quite that way. Let's see if that's going to be our right answer.
Yeah, and you can just see the rule is in resonance structures, atoms can't move. And B, the atoms, those two carbon atoms there, seem to move.
Yeah,
exactly.
It's a pretty weird thing going on. So this is going to be our best answer. Answer choice B for question 191. Question 192. The polynucleotide structure of RNA is similar to DNA. Which of the following statements is true regarding RNA? So we're looking for something that's true regarding RNA. B is kind of a tough one to jump on immediately. tRNA serves as the bridge between the connection of mRNA to amino acids. If you think about it, that's in fact what tRNA does. It's the bridge between, on one end, an amino acid, and on the other end, an anticodon. The other answer choices, though, just don't make sense. You look at A, RNA is single-stranded, yes, with adenine binding to thymine. Doesn't happen. In RNA, you have uracil. And then C says non-coding exons are removed from the coding introns in order to transcribe mRNA. That's not how you transcribe mRNA. And D says rRNA template directs protein synthesis. That's not what ribosomal RNA does. It helps make a ribosome. So A, C, and D are wrong. B is kind of hard to see because of the language, but that's definitely going to be our right answer. Question 193. When the seminiferous tubules fail to produce sperm, the secretion of FSH by the anterior pituitary increases. This is an example of which of the following. Now, a lot of us probably thought, hey, that's positive feedback. Let's look very carefully at what positive feedback is. That's when we have A, and then A is going to make B or cause the making of B, and B is going to cause the making of C. And C is going to come back, and a positive feedback loop is going to cause more A, which is going to cause more B, which is going to cause more C. That's not, in fact, what's going on. In this question, we have the seminiferous tubules failing to produce sperm. So that might be C here. There's no production of sperm. The production of sperm has stopped. So there's no feedback, or the feedback is that the secretion of FSH by the anterior pituitary is increasing. So FSH is increasing, but you can see it's still not causing any sperm production. So we don't have a positive feedback mechanism. The reason this would be negative feedback is once the production of sperm is started, now let's say new example, sperm is started, what that's going to do is it's going to tell the brain to stop the production of FSH. We've got a negative feedback mechanism. The best answer for question 193 is A.
Passage 9, question 194. The edible form of glucose is shown below, right here. And you notice it's edible because it's D-glucose. D stands for delicious. The fifth carbon here, the OH group is to the right. That makes it D-glucose in this Fisher projection. Which carbon becomes the anomeric carbon when the cyclic hemiacetal of D-glucose is formed? Well, let's see what happens. Up here we have a carbonyl, right? This is the aldehyde, and carbonyls like to undergo nucleophilic addition. Alcohols like to behave like nucleophiles. This hydroxyl group here will move around and attack that carbonyl. And that oxygen then becomes part of this ring. So our best answer choice is A, carbon number 1. Right here.
That's just definitional. The carbon group with the carbonyl before the ring formation is going to be your anomeric carbon.
Right. Question 195. When selecting the fastest reagent for an SN2 reaction in a polar solvent, the best option is, well, here we have all the halogens, and they're going from smallest to largest. The smallest one is going to have the most condensed charge, and the most condensed charge then is going to react and bond most strongly with the polar solvent. When it bonds to a polar solvent, it's non-reactive because it's bonded tight to that polar solvent. So fluorine is going to be the worst answer. Iodine is going to be the best answer. It's large. The charge is spread around. It won't bond tightly to that solvent, and that means it will react easily. choice D is correct for 195. 196. What can be stated about the specific rotation of 2R3R dichloropentane in comparison with 2S3S dichloropentane? Well, first we know they're enantiomers because they have opposite absolute configuration at every chiral carbon, and that means that they're enantiomers. So if we take a look, choice D is our best answer. Because they are enantiomers, they have an equal in magnitude and opposite in sign specific rotation, and that's true about enantiomers. The specific rotation will be opposite direction but equal in magnitude. Question 197. Cyclic hemiacetal formation does not occur in which of the following presented. So if we take a look here, for hemiacetal formation, we're going to need a carbonyl and an alcohol. Here we have a carbonyl and the alcohol group, carbonyl, alcohol, carbonyl, alcohol. So all of these can undergo hemiacetal formation, cyclic hemiacetal formation. This one has already undergone cyclic hemiacetal formation, so C is the best answer. It's the one that cannot, once again, undergo cyclic hemiacetal formation. Answer choice C is correct.
That's it.
Hey, Jordan, you've been in there a long time, man. Let's go. We got passage 10 to do.
All right, out in a minute.
Oh, man, I really don't feel too good.
Am I up? Diet not working for you? Yeah, we're doing passage 10. You're up.
Okay. Passage 10, question 198. Which of the following compounds in the body has a similar function or function similar to NH3 in H. pylori? So I just happen to have my NH3 molecule, and I just want to reinforce in your brains, this is a base. It tends to pick up protons. That's what it does in H. pylori. So we have to figure out what in our bodies does the same thing. And of course, the best answer there is going to be C, the bicarbonate. And we've talked about that sort of at length already in this test. The bicarbonate ion is an important base within our bodies. 198, C is the best answer.
Right. A, B, and D are not bases, and that's really all you got to see.
Yep.
Yeah.
Thanks. 199. Surprisingly, patients with gastric ulcers have net H+ secretory rates that are normal. However, lumen acidity is low. What is the best mechanism to explain this phenomenon? So before we go to the answer choices here, let's just consider let's figure out exactly what's going on. H+ secretory rates are normal. In other words, there's enough H+ being put into the digestive network. But the lumen acidity, in other words, the amount of acidity in the lumen is low. In other words, the H+ or the acid must be disappearing. Let's find an answer choice that will correspond to that. I'm looking at D. D says secreted H+ or secreted protons leak into the damaged mucosa and lumen levels appear low. In other words, what's happening is the hole in your intestine is allowing the leakage of this acid out, which sounds unbelievably painful. All of a sudden, my sugar high low doesn't sound so bad after all.
Let's just notice answer choice C. It looks like a good answer at first. Gastrin levels are abnormally high, and H+ secreting cells downregulate their gastrin receptors. However, the question actually says that the gastric ulcers have an H+ secretory rates are normal. So that can't be correct.
Great. Let's look at 200 then. Gastrin is secreted by stomach G cells and stimulates intrinsic factor and acid secretion from which of the following cells? Essentially, this is definitional, and you should know it going into the MCAT. The best answer here is C, the parietal cells. Acid secretion comes from the parietal cells within the stomach.
Right, also called oxyrhyntic cells. Okay.
Question 201 then. Zollinger-Ellison syndrome, ZES, is characterized by a pancreatic tumor resulting in excessive secretion of gastrin. It has also been shown to produce ulcers. Which of the following is a possible explanation for this? In other words, which of the following is a possible explanation for why the ulcers form? We need to know that gastrin, an increase in gastrin production, will result in an increase in HCl level, right? Because gastrin eventually is going to lead to an increase in the acid production by the stomach. But why would this acid secretion result in an ulcer? Well, the best answer here is going to be C. The mucus cells, in other words, in the intestinal lining, the mucus cells cannot exceed their basal metabolism, thus stomach protection remains constant. In other words,
the HCl secretion has been increased, but the basal metabolism of the lumen cells in the intestine is not telling it to increase the production of mucus, so there's not enough protective lining to go around, essentially, and the acid can eat through the lining wall. Great. Let's move on to the last question. 202. 3 decades ago, which of the following procedures was a possible treatment for severe ulceritis? John, I'm uncomfortable answering this question because it makes me queasy.
Okay, answer here is A, decreasing acetylcholine release by cutting the parasympathetic nerve. Believe it or not, it sounds drastic, but it works. Decreasing acetylcholine release because acetylcholine activates the stomach and causes more acid released. Now, what the parasympathetic nerve is that innervates the stomach is the vagus nerve. So the vagus nerve activates the stomach, causes acetylcholine release into the stomach on the cells, and then causes more acid. So answer choice is A.
Good, so that's passage 10 in the book, and I gotta go back in the bathroom.
Passage 11, question 203.
Hey, Smiley.
Question 203. Given the information in the passage, what other animal might use uric acid as its nitrogenous waste product? And it said in the passage, in addition, most reptiles as well as other animals that lay shelled eggs excrete uric acid. And we know birds lay shelled eggs, so this is just a reading comp question. Answer choice B. Question 204. Certain primitive snakes, such as boas, have vestigial pelvic and limb bones. Which of the following is suggested by this evidence? Now, what do they mean by vestigial?
They mean not useful or useless.
Not useful, yeah, left over from evolution, right? Snakes they come from animals that used to have legs, and now they've degenerated. Their legs have degenerated into little tiny buds. So 204, the answer then is D. They evolved from limbed predecessors. Question 205. Why would a 3-chambered heart be a selective advantage for an amphibian? And the only real answer here that makes sense is A, oxygenated blood may come from either the pulmonary or the systemic circulation. This is an advantage to a 3-chambered heart.
Sure. And you can see also how its vocabulary there, the function of the heart is to pump oxygenated blood. So that would be another key for me and something that I'd be looking for. As soon as I saw the oxygenated blood, it'd be a key. That's the function of the heart.
That's good. 206. During dissection of a lizard, a student observes a vertebral column. He concludes that a lizard embryo would contain a notochord. Is this conclusion warranted? And you just need to know phylogeny here. If it's a vertebrate, that means it's in the subphylum Vertebrata, and the phylum would then be?
Chordata.
Chordata, right. So, and then you need to know for the MCAT what chordates have. And so chordates do have what does he conclude? They have a notochord, and chordates have a notochord, of course. So answer choice is A, yes. Members of the subphylum Vertebrata are also members of the phylum Chordata. 207. Which of the following elements is found in uric acid? Now, it said in the passage uric acid is a waste product, and you should realize that one of the things we need to be getting rid of in the waste product is nitrogen. Answer choice then is C. Another way to look at this question is urea is the counterpart to uric acid in other animals, and you should know that urea also contains nitrogen. Question 208. Reptiles produce far more offspring than survive to maturity. This is evidence of A, an R reproductive strategy, B, a K reproductive strategy, C, speciation, D, negative fitness, or E, a good sex life. Jordan?
Best answer would be A, an R reproductive strategy, because, and I have a little mnemonic here that I encourage you guys to use. R is for rapid. You rapidly make more. And K, kid-centered. So K, if you're a K reproductive strategist, you're kid-centered. You make one child, you nurture them, you love them, or you make few children, nurture them, love them, and they grow up and become great.
Good. So you're kindly to your children, starting with K.
I like it.
Okay. So basically an R strategist then puts its energy into making a lot of babies. A K strategist puts its energy into upbringing a very few babies.
All right, the last set of freestanding questions in bio here.
Starting with 209, as with some herpes viruses, certain parts of the human cytomegalovirus genome have considerable homology with mammalian eukaryotic DNA. Based on this information, which of the following statements is most likely true? Now let's read this question very, very carefully, or you're not going to get it right if you don't read it very carefully. They're asking about why certain parts of this virus's genome have considerable homology, in other words, considerable likeness with mammalian, in other words, eukaryotic DNA, mammalian eukaryotic DNA. Why would those two be similar? Let's look at the answer choices and find out. A says cytomegalovirus has acquired human cellular genes during evolution. Does that make sense? A virus could attack a mammalian eukaryote, and in its progression, in its own progression of life cycle, in its own evolution, part of that eukaryotic DNA may be incorporated into its own. A makes sense to me. Good. A is the right answer to this one. If you chose D, cytomegalovirus has mimicked mammalian genetic evolutionary development. If you chose that one, really what you did was made an assumption. You thought, oh, well, that's just a similar segment of DNA. It's not likely, right? The question asks which is most likely to be true. A is definitely the answer. Question 210. John, you want to take this one?
Let me take this one.
All right.
PAS stains glycogen and mucopolysaccharides well. That means it stains carbohydrates, basically. Which of the following structures will most likely present PAS stain deposition in chlamydia? Chlamydia is a bacterium, so we're looking for where we might find carbohydrates in bacterium. The only place here where we find carbohydrates in a bacterium is the storage vacuole. Nuclear DNA, there's no nucleus in a bacterium. Lysosomes, no lysosome. Cellular membrane, there's no carbohydrates there. So answer choice there would be B, best answer.
211 then. Energy required to break old bonds is at least partially compensated for by the formation of new bonds. The correct molecular description of the above reaction is, obviously when we're looking at the above reaction, we've got a hydroxyl group on the left-hand side attacking a carbonyl carbon, and it's breaking the double bond between that carbonyl carbon and the carbonyl oxygen, meaning this is by definition an addition reaction. Answer choices, yeah, C and D can't be right. Now the question is A or is B the right answer? A says an addition reaction with a pi bond weaker than a sigma bond, so it takes less energy to break it. Or B says an addition reaction with a pi bond stronger than a sigma bond. We could stop right there because we have to know that a pi bond is going to be weaker by definition than a sigma bond. A must be the best answer. 212. A man with disease Z mates with a normal woman. They have 3 boys and 3 girls. All of the girls have their father's disease, but none of the boys do. What inheritance pattern is suggested? Now, of course, if all of the girls have the father's disease, but none of the boys do, that's obviously because all the girls are getting their X chromosome from their dad, and all the boys are getting their Y chromosome from their dad. So let's draw the cross up here. And we've got dad on top.
Right. So what that indicates is that the father's X chromosome is diseased, not the Y chromosome.
Great. So the dad's X chromosome has to be diseased. All the girls are getting it and none of the boys because none of the boys are getting dad's X chromosome. So let's find the answer choice. It's obviously got to be X-linked, making it answer choice C or D. And in this case, because the dad's disease gene overcomes the mom's, it must be dominant as well. Best answer for 212, D. 213. We got the structure of penicillin 5. The above compound is an important antibiotic that contains how many stereogenic centers? So you have to know that stereogenic center is just a chiral center or chiral carbon, meaning a carbon with 4 different substituents. And we got to find in this molecule, we got to find all the stereogenic centers. So let's find them. We've got one right here because we've got 1, 2, 3, 4 different substituencies. Another is right here, and then the last one would be right here. So we've got a total of 1, 2, and 3. 3 is the best answer. That would be answer choice B for 213. And finally, 214. Structures inside sperm cells are actually modified parts of a typical cell. What part of the sperm would have the highest lysosome concentration? So obviously the lysosome concentration is going to be the place where we're going to find digestive enzymes, and that would be found in the head or the part of the sperm that has to penetrate through the egg. The head of the sperm is called an acrosome by definition, and you need to know it. 214, best answer is C.
And that's all there is for test 3. Thank you very much.